All right, welcome everyone. Thanks for coming to hang out with me for the next hour. We're going to talk about this slide in just a minute, but before we do that, let me introduce myself and the topic we're going to talk about today. So my name is Pete Krukenberg. I'm a software developer at Weave. If you came down from the north or you're heading north tonight, you'll see our building just off to the east side of the road. It's got a logo that looks just like this. And just a little bit about Weave, since they're giving me the time to come present today. It's a little hard to describe, so I'll describe it in two ways. So we're an all-in-one platform for interacting with customers, patients, pet parents. Our customers are dentists, optometrists, veterinarians. The other way I describe it is if you are able to set up an appointment with your dentist, make a payment, get a reminder, all without having to make a phone call to them, there's a pretty good chance that they're a Weave customer. I also should mention that we are hiring. We actually have an opening that just opened up recently for our head of security. So if you're interested in knowing more about Weave or that position, go to our website or come talk to me afterwards. I'll be hanging out here at least for a little while after this. Would love to tell you more about our company and what it's like to work there. Okay, so let's talk about what's wrong with this picture. And I apologize, I had to kind of guess at most of this, but let's go back here for just a second and see how close I was to what kind of problems. So this is the audience participation part. What's a problem? Tell me a problem that you can see with this scenario. Yes?
The developer has access on a system.
Yes. So, and what's the problem with that? What's wrong with developers being able to get to a production system?
There's a lot of things, but one thing is usually your compliance frameworks, like say PCI and that, like you're not compliant. Which most people want to take payment cards.
Right. So usually compliance and just good practice is to have a separation of responsibilities, that the person writing the code can't also be in charge of how it gets deployed into production. Good one. All right, another one, maybe somebody over on this side. Just shout it out. In the orange there. CI/CD. Okay, so tell me more about CI/CD. What's the problem there?
He's doing a bunch of manual steps that
But he's probably really competent and he's been doing it for a long time. Right? Okay, orange shirt.
He's only testing on a single system.
And that single system isn't even the same as the one that's being run in production, right? And there was one up here.
I was going to say revision control.
Okay, tell me more. Revision control.
He's just making backups, but he's not really storing them anywhere in a way that you could revert if you needed more than numbers.
Yeah. Okay, Dave?
Fixes code on the prod system, probably doesn't push back to test or dev.
Yep. Okay, so a couple more maybe on this side. These are all really good. Yeah.
Patch cycling it. He's cautious about it. I'm guessing he's not doing it.
Yeah, so how likely do you think it is that that server has a bunch of vulnerabilities? Pretty likely, right? Okay, so last question. How many of you have ever worked in a place where something close to this actually was going on? Okay. Hopefully, I'm not going to ask the second question, how many of you are working there now? But no, this is a pretty real thing. So what I want to run through today is kind of the basics of what I'm calling modern software development. It's I don't know that it's modern other than, because I'm sure there are plenty of people that still work this way, unfortunately. But it is stuff that solves those kind of problems in a pretty good way. So what I did was, I don't know that this represents everything that we just talked about, but I'm going to try to go through and show each of the kind of basic components of a modern software development system. I'm going to actually try to do this live, and hopefully that will either be entertaining or educational. And then I'm going to try to point out how each of those things addresses each of these issues that I have on this list. Okay, so just very high level, when I talk about modern software development, I think of two specific pieces. One is code versioning, which is this ability to keep track of changes over time, as well as have your code somewhere else other than on your server. And those usually go together pretty nicely. The other thing is this idea of automating everything. So somebody said CI/CD. The general idea there is, rather than somebody manually performing these steps and hopefully hoping they do them correctly, that we can build all that stuff. One of the terms that we use is something as code. Infrastructure is code, test is code, code checks is code, deployment is code. The idea here is let's put that in a machine-readable format that then we can look at and say, this is what we want to have happen, and that happens the same way every time. The other thing that we try to do with this is more focused on the developer side. And as a person who once ran in a scenario way too close to that to feel comfortable, needing to know not only how to code and all that comes with that, understanding the customer requirements and interacting with the different parts of the company and other developers and so forth, having to be a good sysadmin, a good operations person. That's just a lot for somebody to keep in their brain. And frankly, from a developer perspective, those things are pretty annoying to have to do. So the other thing we try to do is get as much of that off of the developer's plate and into the system. So we're not trying to move it to another group like the ops group. We're trying to not have a human have to do it. So the piece of stuff that we don't want to have to do, we call toil, which I think is a great word. And then cognitive load is what the developer needs to keep in their brain to do something right. A few other terms that you may have heard that kind of all fit into this. These two concepts are kind of the foundation for DevOps. There's now NetOps, FinOps, DevSecOps, different combinations of those things. The idea that teams work together to deliver reliable software more quickly. You may have heard of microservices, the cloud, Kubernetes, containers. I'm not going to cover any of those things today. Okay, so the plan in the next 45 minutes is to try to cover a bunch of this stuff. I don't know if we'll get through all of it, but we're going to build a Hello World app. I'm going to show you what Git works like. It's a code versioning system, what GitHub works like. Then we're going to do some automation. We're going to write an automated test. I'm going to show you how to do some workflow things, this idea of having something else do the work for you. And then if we get time, we're going to look at Docker for deployment. Okay, here we go. So I'm going to be using GitHub Desktop. I generally don't recommend using this, but I'm more of a command line Git person, but I think if this is the first time you've seen Git, it's a good place to start. Okay, so we're going to start by creating a new repository. We're going to just call it modern. And a repository is essentially a storage place for code that's set up to be able to do the things we want to do with tracking history and who did what. Just some niceties. We're going to be working in Python, and so we're going to create that. And then we're going to open this up in Visual Studio Code. And I apologize. Let's see here. Okay, so we've got our directory here, and the first thing we're going to do is just create a little simple web server. So, and I'm going to copy that from this thing I already wrote up. And let me increase the font size on this. Can everyone see that, like in the back? Can you see that okay? Raise your hand if it, okay. All right, and then let's, hang on a sec here. Okay, I wanted to run a terminal, but the little button that I had for terminal is not showing up. Okay, I'm going to switch over here. All right. Okay, so I'm going to just run this. Got to remember to save. There we go. All right, and cut and paste properly. Oh, there's the problem.
Versus spaces.
Apparently, all right, I gotta, apparently I did not get all of the files that I needed here. So let me, okay. So let's open that up and see if it actually works. All right, so we got hello world. Thank you, thank you. All right, hopefully things don't continue like that. Okay, so we've got all right, so we've got some code ready. Let's go make a commit. So a commit is basically a record of the changes that were made. We're going to make it into our repository. One of the things that goes along with a commit is a little description, who made it and when it's made. So we're going to just say, and we're going to commit. And then we can actually go look at, so we haven't done anything outside of our machine yet, but we can actually go look at this commit, and we can see that I made it, and we can actually see when it was made. It actually has a timestamp in there. All right, so let's make a small change to that and just show how a small change looks. So we're going to change this from being about the earth to the people. And if we go back to our changes now, we can see this is actually really nice. It shows us exactly what's changed between these two. All right. And let's run that again. And there we go. Okay, so what we have so far is keeping track of the changes that were made, but they're still on our local machine. So we don't have any way to get them to the server. We don't have any way to recover them if they get lost. So the way that we solve those problems is we use a service called GitHub, and we're going to publish this repository to GitHub to do that. Oops. Okay, so we're going to call this. I forgot to delete my repository on GitHub. Okay, so we've now got this on GitHub. Let's go take a look at what that looks like. So this is GitHub, looking at our modern 2 repo. What I should see here is the same thing that we were looking at on my machine. So if I look at the commits here, there are the same commits that we just made. And then I can also go look at, is this file the same as what I expect? Yes, it says, hello everyone. And so at this point, I could actually, this gives us a couple of benefits. One is that we have a backup now of the code. If my machine were to lose all of that, we could go get it off of GitHub. This also is available to anyone who has access to this repo. So just by having it on GitHub, one of the problems that can be solved is, I think I'd pointed out that nobody could actually see that code that Bob was developing on his machine, putting on the server, unless they went and talked to Bob. Well, now a security person could have access to GitHub, and you could at least inspect the code. This also solves a little bit the problem of Bob, what happens if he gets sick, or if he's on vacation, or if he leaves. Now somebody else could actually get this code and deploy it. All right, so let's look at one other concept with Git. Git has this concept of branches, and I'm not going to go into this in detail, but Git is kind of set up like a tree structure. So one of the things that you can do is create kind of a branch off of that tree, and it's called a branch. The idea with that is that you can then work on that code base while other developers might be working on it. You can make changes to it separate from that, and then when you're done with those, you can put those back in, merge them into the main branch. So as it shows here, we're currently on the main branch. We're going to create a new branch. Someone decided that we should be responding in Spanish instead. So we're going to create a branch. We're going to then go into our code. All right. So now when we make this commit, we're going to be committing it to this separate branch. So okay, so I'm going to publish this branch. And remember last time when we published, when we went to GitHub, we saw the changes that we had made. But if I go look at this, what's in the main branch, it still is, there's no Spanish there. If I want to be able to see this change, I have to switch the branch here as well. So if I switch over to the Spanish branch, there's the Spanish translation. Okay, so one of the things that, so this is useful, but really this is where the power of this combination of branches and Git in GitHub, we can see kind of the interaction between, or the ability that provides to let somebody else inspect the code or inspect the change before it's committed to the main branch. So I'm going to show you how that works. We're going to create what's called a pull request. What a pull request is I made a change to this code. I would like to propose that we make this change, and with the intent that if it's approved, it'll get pulled into the main branch. So I'm going to create a pull request here off of the changes that I made. Okay, so usually this next process would be handled by somebody else, but for today I'm going to have to switch to this other persona who's going to review this code review. So again, this is proposed changes, and if I were to ask somebody to review that, I would say, can you go look at pull request number 1? The reviewer then can go look at, these are the changes that we want to make. I want to change it to Spanish. These are this is the actual change that's being proposed. And then they can actually make comments, they can approve this, they can request changes. So let's add a comment here. And one of the big problems with this is that I believe there's supposed to be an accent on this. I might be wrong, but so I'm going to say, okay, and then I'm going to okay, so I'm going to submit the review with that comment. So switching back to the person who submitted this proposal, this is what they see now. They would see that somebody had started a review and that they made this comment, and oh yeah, I totally should have done that. So I can actually take this little change here and just say, yes, add the accent. So now in my commits, I've now got the original one as well as this new add an accent. All right, so that looks good. So I'm now going to merge this. Okay. Sorry, I didn't hear that. That's a whole other topic. It's that tree structure that I was talking about. There are different preferences about this. I like to keep my tree very straight. A rebase lets me add that change onto the end of that tree of commits. A merge it retains that branch, and so in the history I can actually see that branch. To me, that it's a little bit messy, so I don't like to do it that way. I prefer to do the rebase way. That is a topic like Windows versus Mac, Emacs versus VI. So kind of a personal preference with some reasons behind each. Okay, so now in this, good question though. So now I should be able to see, yep, there's our Spanish. Now let's go back to our local environment. So we don't have the accent here, and actually we're still on the branch. So how do we get that back? Well, what we need to do is switch back to the main branch, and then we need to retrieve those changes. So Git works in kind of this peer-to-peer fashion, and so I can keep a copy of it on my local machine. I can also keep a copy in the cloud, and I can decide when to synchronize those. So in this case, we're going to now pull that down, and what I should see in here is, okay, let's see, did I get, okay, I got those. I probably have to open this up again. There we go. VS Code is not my normal editor, so I'm trying to learn it as I go here. All right, so now we've got that in there. All right, so we've now added, let's see, I think we're doing a little bit of a checkpoint here. Okay, two other things. So let's say that after we do that, we get some feedback that Spanish is not the right time to translate into Spanish. How do we undo that? Well, we have two ways that we can do it. One I'm going to show at the command line here. So one is I can actually, so I've got this long list of commits. I can either undo those commits, or I can actually say, I just want to work with the code at this particular commit. So in this case, I'd want to work with this one. And I can just do that. And then if I look at my code again, we're back to the original version. Now, those commits are also there. This mechanism is one of the ways that we do releases. So we might say, I want to release as of this particular commit, and I can actually do a deployment based off of that particular commit, even though there's later stuff. But in this case, we actually don't, we've decided we're not going to be adding Spanish for quite a while. So we're going to go back to the desktop, and we can actually revert these changes. So this adds a new commit that undoes that commit. Let's see if, okay, so I'm now going to undo those two commits. And let's see here, hopefully. Okay, so we're now back to where we would like to be. And then I need to synchronize those to GitHub. So then back on GitHub again, I should be able to see the same code that we've got locally. All right, there we go. Okay, so let's do a quick check-in on kind of how this affects those problems that we were looking at before. Okay, so with Git and GitHub, we don't have to worry about software being copied incorrectly, because one of the things we can do, as somebody mentioned here, is we can pull that code down to the server. We don't have to worry about changes getting lost. We're covering our history, outside visibility. We have a way to get at the code if Bob quits, and we don't have to do those manual code backups. Okay, so what about testing? Actually, let's go to this slide. So this is how this changes the process. So Bob now does the coding and testing on his machine. He now commits with Git and pushes to GitHub. And then he SSHs to the Linux server. He retrieves the code from GitHub. He does some quick testing. If he does make a change on the server, he can now push that to GitHub. Or he can check out an earlier commit like we showed. So it's getting better. All right, so back to, so how do we address testing? All right, let's first start by, in our code, we can actually add an automated test. So let's do that. And hopefully this one pastes a little bit better than last time. All right, who said something about how I fixed the indentation? Like I had to select all or something like that? Maybe that person left already. Oh wait, it's actually this. Okay. There we go. Okay, so let me fix my test so you can see here that what the test is checking is the response that we're giving what we are supposed to be giving. And let's go look at our test. So in our code, we're saying we're going to send back hello everyone, but in our test, we're still on hello world. Oops. All right, so now our test passes. Okay, so we have a way to be able to run the test. So Bob can now run the test before he commits, before he puts it on the server. What we'd really like is to not have to rely on him doing that. So this is where we're going to use something called GitHub Actions. And the idea with this is one of the automation steps. So what we're going to try to do is set up something that every time somebody creates a pull request, it runs the test. And then they don't even have to think about it. So we're going to add to the way that we add that automation, we put that under a directory called GitHub Workflows. And we're going to add to that a file we'll just call check. This is going to be defined in YAML. All right. Okay, so what this action is going to do is check out our code. It's going to install some Python stuff into this environment, and then we're going to run the test. This is going to run on essentially what's a container, but it's a virtual machine in the GitHub environment. So I don't have to do anything to be able to set that up, other than I'd say I want it to run on Ubuntu, and then it's going to take care of the rest. Okay, so we're going to create a branch called test. And I'm going to bring that change over. All right, and then let's look at the changes. So what I should see here is my test and my action. Sorry, can you?
So where do you get the YAML?
GitHub documentation. Yeah, just if you just do a search on Google for an example of GitHub action, there's plenty of them. I think I probably took that from one of them. Okay, so I'm going to create a pull request here. All right, and now we're going to see if this worked. Oh, awesome. Okay, so under this Actions tab, this is going to show all of the GitHub actions that I've run. And it will show the detail of what happened. So this is pretty close to if you had run it yourself. So we can see that it checked out the repo, it did the setup, it did the dependencies, and then it ran the test. And we'll actually see the same output from the test that we saw in our local machine. So just to make sure that this is working, let's break our test and again, and we'll push that again. So the cool thing about this is extending that branch concept. Now not only can I do development on that branch without interfering with anyone else, I can actually play around with what it takes to make my branch pass all of the tests, and nobody else is affected by it. Okay, so I'm going to push that. And go back and look at, so each of these action runs will be logged kind of separately. So we see the first one that passed there, and then this one, we should actually see it fail. And there we go. So there it failed. Okay. Okay, so at this point, one of the things I had promised was that I would show you some ways to, so we talked about a couple of basics. I had promised I would show you some ways that you could exploit these. So this is where we can start doing this kind of stuff. We now have stuff in our repo that executes commands. Essentially that if we go back and look at this, if we look at our YAML, okay. So this looks kind of like a shell script, doesn't it? In fact, that's actually what's happening here. This run command basically says, take the rest of this and run it as a shell script. Well, you can do some pretty interesting stuff with shell scripts. That's one of the things that you can do here. So let's start with something really basic. One of the problems with the way that Bob works is how do you make sure that secure coding practices are happening? Your only option is to go talk to him, maybe sit down with him and have him look at the code, but that's pretty cumbersome. Wouldn't it be awesome if there was a way that you could make it so that certain security checks happened every time a code change was made? Well, let me show you one way that we can do that. So a really basic one is, let's add a linter. So we can go into this workflow. Oops. And we can add another step. And this, because you would have access to GitHub, you could actually do this either with or without Bob's involvement. So we're going to check to make sure at least that the code doesn't have any kind of egregious errors. Okay, so let's fix this test so it doesn't fail on that. And then let's add a linter, something that we know will cause a problem with the linter. So this should cause a problem because it doesn't have parentheses around it. And then let's push that change. So one thing that's kind of cool about actions is that, wait, did my linter not get added? I thought it did. Let me go look at the changes that I made and see, did I add a linter? No, apparently I didn't. Probably because I didn't hit save. There we go. Okay, so one of the things that you might notice is that every time this action runs, it does the same thing over and over again. This might be kind of annoying if you're having to wait for it, but it's really good in that it runs the same thing exactly the same way every time. Okay, so there we go. We have a linter built in. So if Bob were to check in bad code, we would at least get this check. I'm not going to show this just because I want to move on to another exploit, but one of the tools that's really awesome for static analysis of code for security issues is called semgrep. Does anyone know about semgrep? Yeah, it's good to see a few of you. So semgrep actually has an action that you could add just as easily as what we did with lint. It does many more checks. It can do checks specific to the language you're working on. It can do checks for other things about the environment. And it comes with a ton of them that I guess SEMGRAP or the community have created, but you can also create your own custom ones, and it's pretty easy to do. So linting and SEMGRAP, I would say, are probably, linting, SEMGRAP, and tests are three of the most basic ones that are easy to add. They catch a ton of things that developers might not notice kind of in their rush, or they just might not be aware of. Okay, so let's look at one other. I'm going to just show a way that you can get to where you could exploit some more about this environment. So this thing is a Linux machine running this shell script. Wouldn't it be cool if you could SSH into it and maybe poke around a little bit? This might be helpful if you're trying to debug, but from a security perspective, it might be interesting to see, like, what is this thing and what kind of stuff could I do inside of this environment that maybe I could use for other purposes. One of the interesting things you can do with actions is we're showing actions triggered by a pull request, but actions can also be run on demand through either the API or the GitHub API, or there's a little drop down in their UI. You can also set them up to run on a cron job. So think about some things that right now you have to do, either from your machine, or maybe you're trying to figure out a way to set up something to run somewhere. Actions might be a way to do that. So let's add in this ability to SSH into it. So we're going to just add this action, and then, okay, so we're going to just run this right after we get the environment set up. Okay. Okay, so what we're going to see here, if it works, is it's actually going to stop our flow and tell us how we can connect to this container that is running our workflow. So if I click on this link here, hopefully it connects. Oh, we can also run SSH if this doesn't work, but okay, let's try the SSH command. Oops. Okay. All right, so there I am inside this environment. So I've got my code there. We can see that this is oh, that's interesting. This is apparently running something with Azure. And so this is Ubuntu. I don't know, what kind of stuff might I be able to do with Ubuntu? I don't know if it, let's see if we can run curl. Well, I can do that. I don't know, a lot of possibilities there. Outbound network access. So couple ways that you can exploit. That second one probably has a lot more opportunities. All right. Okay, so let's go look at where we're at again. All right, so we have added some automated tests. We've added some GitHub actions. So we've now taken care of checking coding standards, testing under pressure, how is the site tested, and the only things we have left now are like, how do we get this software onto the server and without having to involve Bob? So this is what the workflow looks like now. So Bob now writes code and test on his iMac. He pushes that code and tests to Git and GitHub, and then those tests and other code checks run automatically. And then step 3 is pretty much gone. I guess there might be some value in testing it, but with a good set of automated tests, don't need to do that anymore. So we've just got this last piece of how do we get this thing onto the server? So I'm going to show an example of that. And let me just say that that piece is actually a whole other talk about infrastructure automation. So I'm going to just show a small piece of how this works and elaborate a little bit on how that automation might happen. Okay, so we're going to use Docker to create a container. This could also be, so I'm going to use Docker as an example because I can run it here on my machine. But what we're looking for is automating this process of keeping the server up to date. More importantly, what we want is to have a consistent environment. So we know that when we run this Python code, the environment is going to be exactly the same way that we expect it to be. So Docker is one way we can do that. We could also use, if you were using, for example, virtual machines, you could use something like Ansible or Puppet or Chef to kind of automate the management of that. If your Docker creates what are called containers, which are like kind of small virtual machines, those typically are used with something like Kubernetes, which is like a whole separate topic. So we're going to just leave the how it gets automated as a topic for another time and just show you an example of what that automation could look like. Okay, so we're going to add to our repository what's called a Docker file. Oops. Oh, I'm going to type Docker file. Okay, so this is super simple. Let me just explain kind of what you could do with this. So this from is, we're going to start from an image. So this would be kind of like the ISO you might download for an operating system, but it's actually prepared in a certain way already. So in this case, we just care that we're going to run Python, and we want to make sure it's version 3. That image is actually an official image created by the Python, I don't know, community or I don't know, somebody that knows what they're doing. So if I want to run Python, I can actually trust that is going to have the right environment. I could actually be even more specific. I could say, I want to go get this particular version of that Python 3 image and make sure that it only gets changed when I control it. But for our exercise today, that's not necessary. And then I'm going to add this server.py. Well, so what's going to happen in this is when we build this image, it's going to copy that file from our repo into the image, and then it's going to run this command, Python, just like we've been running. So I'm going to just run this locally. Oops. Okay, so Docker, well, that was pretty quick. So Docker just built that image. I can actually see it here. There's the image sitting in my Docker repository. Similar concept, but for images. And now, okay, let's make, so it's on 8,000. We're going to put this on 8001 just so we can show that we're connecting to the Docker container and not the server running locally. And oh, look at that. It couldn't run it because we still had that broken code in there. So let's go fix that real quick. And then we'll rebuild that. All right, so there we go. So there would be a couple of other steps once we built this image. We would have to somehow get that image onto the server, but that is also something that could be automated with that whole process. So with that, you've gotten kind of a brief overview of all of the basic components of modern software development. Going back to our little diagram here. So we're using Git and GitHub to store the code and track changes. We're adding automated tests. We're running those tests and other checks in an automated fashion where the developer doesn't have to remember to do it. And now with Docker or the other ones I mentioned, we have a way to control the OS environment, and we have some documentation on what that environment looks like. And, oh, I forgot to mark this one off, running the wrong software. So we've checked off every one of these. And the last change there is that Bob now just checks in his code. We still have to solve this problem, but automation is going to admin that production server. So I hope with this, one of my main goals was, if you're doing development, here's some things that if you aren't using, might be really helpful. I would definitely recommend them if you're not already using them. A little bit of ramp up time, but it's kind of the spend a day or two to save yourself time over the next however long you're a developer. The other thing I hope is this has given you some perspective on what is either happening in your development environment with the developers that you might work with as security professionals, or what should be happening, and give you some way to kind of relate to them, maybe understand what's going on with what they're doing. So thank you very much for your time. I hope this has been really helpful. I think we got a couple minutes for questions. I'll just hang out here until the next speaker comes up. So.
Test, 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 test. Check. Check, 1, 2. Test, test. A little bit louder. Okay. Well, thank you for coming to my presentation. I'm glad to be here. We all know that security has blind spots when it comes to software development. And software engineers have gaps when it comes to security. So oftentimes they look to, businesses look to application security departments or an application security person to fill those gaps and to expose those blind spots. And as application security professionals, we get sent down a hunt for developer training. And this can be very painful, and if you've ever had to do it. And in fact, if you've been in some other talks, you may have seen that this is kind of an underlying theme here at SAINTCON, that our current training isn't really working, especially highlighted in Snow's keynote earlier. Developer training seems to be everywhere, but if you take a look at developer training, really drill down into it, a lot of times it's just relabeled pen tester training, or sometimes pen tester lab walkthroughs. And this may not immediately seem like a problem, but there are fundamental differences between how pen testers and software engineers need to approach security. So oftentimes developers aren't even interested in pen tester training because it's not immediately practical for them. And sometimes as security professionals, we have a hard time getting our head wrapped around how training for developers should work if it didn't include pen tester training or some sort of breach training. So how can developers code secure without becoming hackers? Well, the short answer is by promoting fundamental practices that target fundamental security concerns. And I'd like to help give my impressions on why a lot of the current training isn't working, and why software engineers, the software engineering approach to training is a little bit better when it comes to security training. for, obviously, software engineers. Then we'll look at some key points recommended that I would recommend to be in your developer training. And hopefully I can give you enough that when you go back to work that you can at least search for training that can help your developers get there. So who am I and where do I get my insights from? Well, my name is Alton Crossley, and they call me Names. That's my Twitter handle. But I'm an application security engineer, and I am a Microsoft Certified Solutions developer, as well as a certified ethical hacker, and some other security certifications. I have 20 years development experience and a background in network engineering. So I've made that transition from developer to security, and I've worked security from both sides. So let's talk about the pen tester approach and why I don't think it's quite appropriate for training software developers. So pen tester may start their test. When they start testing, they start with a cookbook. A lot of times, sometimes they'll even use a DAS tool to get them started, because there's a lot of common mistakes that are made in software. And right away, this is a good indicator that the current training methodologies aren't working, because it has created a pattern of common vulnerabilities. Then after this stage in a pen test, a pen tester, of course, will go and try and use unconventional methods to use the application in order to get access to data that they shouldn't have access to. And developers, when they look at this practice, they a lot of times relate it directly to quality assurance, QA testing. They kind of see all testing as the same. And you'll see discussions on occasion that security assurance is a subset of QA, or security is a subset of QA. And that it can be true from a developer's perspective. And we know there's a lot of crossover between those two groups. And of course, when there's crossover, you would expect us to have a Venn diagram on the next slide, because we're nerds. But what I'd like to do instead is show a diagram from ISO 25010. And what this is it shows how security is a specific subset of software development quality assurance. So this is from a software engineer's perspective. And sometimes if security is our primary focus, we might forget how important these other things are, and that security isn't the only important thing to everyone in software development. But what this, of course, doesn't show are the other practices of security, of application security, especially governance, compliance, incident response, things like that. So there's definitely two sides to this coin. But the takeaway here is often developers don't get credit for security aspects that they're already covering, or even QA is already testing. So if we as security professionals kind of find a way to anchor there and kind of build out to encourage fundamental security practices. And sometimes having QA work together with security can really create a synergy. I hate using that word, but it's kind of a good foundation. Having 3 pillars is much better, just like a stool needs 3 legs to stand on its own. So it can really create a lot of useful crossover there if you work together. So let's go back to that unconventional ways of using software that a pen tester does. When a pen tester tries to make software do things that it's not supposed to, and are successful, sometimes they get a great bump. It's very addictive, get a little bump of serotonin. And it might really, that's kind of the addictive part of being a pen tester, right? But sometimes what's overlooked is the way that software engineers may see the same events. A seasoned software engineer is able to create functionality that's reliable, it's consistently reliable, and yet it's flexible enough to operate in multiple circumstances. So, in fact, a developer gets a profound thrill sometimes when they learn that somebody has used their software in an unconventional way. It's like it's a live moment that it really separates the builders from the breakers a lot of times, but it's the same coin, two sides of the same coin. Individual developers they have to learn how to guide their own monster, but they also have to work together with the rest of the team under the governance of architecture and the engineering standards that they have. So they have to use a specific way to solve their problems and a specific context for bringing in security. So you might ask the question, is flexible code insecure? Well, flexibility doesn't necessarily make code secure or less secure, but it does make a big difference when it comes to the way that they respond to flaws. So when a vulnerability is pointed out and code needs to be changed, inflexible code will often require a change in another place. So they'll change it in one place, it'll break in another, and it's like juggling sand, just in order to keep baseline functionality. And because of this, maintainable code does become a security concern. And to illustrate this, we'll kind of step aside from code exactly, and we'll talk about circumstance in Pennsylvania, 3 Mile Island. Some of us might be familiar with this. And this quote's taken from a documentary by Kyle Hill. But basically, in the control room at 3 Mile Island, investigators found key indicator lights on the backs of panels, switches out of calibration, and tags covering warning panels, and never fewer than 52 alarms blinking at all times. Over 100 alarms would sound when the reactor started to fail in Pennsylvania, and it was impossible to sort the critical ones from the usual. So the point here is that at one point the reactor was running fine, but when a small thing happened, it took a long time to figure out what it was, and it took even longer to fix it. The lack of transparency that they had internally then caused communication problems, and then it became a public relations nightmare. If you look at some of the documentaries, you come to understand that 3 Mile Island could have been insignificant, but it wasn't. And what we want to take away from this today is that they didn't finish with detail. In software, the control room could be likened to DevOps, from planning through code to operations. And the longer a problem exists, the harder it is to fix. And of course, the more data can be lost, and the more costly it becomes to fix. And so a messy control room, as it were, runs a high risk of failure and eventual breach. And just like with the nuclear meltdown, this can't be taken back. We've seen this time and time again. And I would consider 3 Mile Island as a good example to parallel code with a finish of about level 2, when it should have been code finish of level 5. So what is code finish? I'm talking about software finish levels. And so here, obviously the definition of finish, the manner in which a creation of an item is completed in detail. So it's the craftsmanship. Finish really has nothing to do with anything like agile frameworks or how secure the application is to begin with. Really what it does is it focuses in on the code and how that code is produced. It touches on code readability, code organization, naming conventions, things like solid and dry, and infrastructure as code also plays into this. Unfortunately, it's really common for applications to be of level 3, have a level 3 finish. And the reason I point that out is if you're used to a level 3 finish, you may think of security and quality as something that's very hard to achieve and very expensive, whereas with a level 5 finish, this isn't the case. And a level 5 finish is achieved with organization and teamwork, and some people on the team having very specific skills. And it doesn't take more time to have a level 5 finish, but what it does do is it saves time again in the support of that and responding to flaws. So software finish actually can be as effective as architecture, technical design, and security assurance. And you might ask why? Well, let's take a closer look at this level 5 finish. The reason is because it's well organized and it's clear what's being done. That makes turnaround of flaws much more efficient, and changes can be made with confidence. When they make a change in one place, it's not going to affect another. And when there is a meltdown, the application is transparent to the developers so they can figure out what's going on. And oftentimes it enables solving issues on a systemic level rather than just line by line. And this is because level 5 finish engineers are not line level myopic. Some testing tools, in contrast, might point out, if you've used any SAST or DAST tools that look at code, they'll point out lines that they think are the reason or that might be a risk or that are a reason for a flaw. And sometimes they offer fixes for just that line of code or a solution for the vulnerability, but they usually ignore the architecture and the engineering standards that might be present already. And so when software engineers are told that they should observe these as best practices, it conflicts a lot of times with their other expectations. Level 5 engineers, though, if allowed to their own ways, are able to understand the context that the tool gives them, because that's what it is to them, is context. Then they encourage the team to build a module that's well tested, and then they use that module as a standard. And so that has a much broader positive effect than a line level fix. So we as security professionals should allow them to make this better, sorry, I lost my place. We should allow them to have a better solution, more complete solution, a better design. Don't give them a hammer when they should be using a jig. There's a limit to, of course, what influence application security can have over the development process, but making sure that they have the tools and that encouraging foundational practices can really make a difference. And security training should include a lot of these foundational things. So one of the things that I want to point out that's very common, and this plays into the last talk if you were in here, which is really nice. Foundational practice that I see that's common among those doing security development very well is handling merge requests well. Having a standard for merge requests or pull requests, whichever terminology you use, is really important. You can have branching strategies that vary widely, but having a good standard merge request policy is really important. Always require at least another person's sign-off other than the person creating the code. And this is when we're talking about contributor merges, so a single person's changes, so that another person can have eyes on. And make sure that they're using a tool that the merge can be commented on, and then they actually have a exchange of knowledge. And ideally, when this merge request is created, multiple security tools would be kicked off and would also decorate that merge. So you're running SAST and DAST and SCA all within that merge request. So then it can be a part of a discussion and an interchange of knowledge. And this is also where code review scales. So a lot of times we look at code review as a big daunting task of reviewing the whole application. But if we train the more senior developers in security review, then they can take a look at this with an eye to security. And so this merge request is very important. And because the merge request is important and the information in it is important, what can happen sometimes is the tools can be too chatty. They might overwhelm with a lot of useless information, or they may not integrate the way that the developers want to. So the other side of that coin is that as security professionals, we have requirements for reporting and tracking. And tools don't often do both of those well. And so sometimes having separate tools for devs and assurance, security assurance, is important and very useful. because you can also hand off some of that responsibility to the developers to for their scanning, so that they can get the information that they want where they need it. And it doesn't, you can give them that freedom, and it doesn't affect your outputs that you need. And I'm not the only one that has suggested this in the past. And I'm also not the only one that has suggested this either. Using a framework is really important. I think is one of those things that we can, it comes up often, but it really is useful. A couple of simple frameworks that are easy to implement. The 4-question framework for you doing threat modeling is really light and adaptive, so you can just integrate it into agile functions. So different meetings that you have for agile, do it, rituals is the word that they always use. You do it during any sprint ritual. Also having a development team fill out the SAM evaluation can also open, just filling it out once can open their minds to kind of some of the things, the activities that can be done that can move the needle. So that's pretty useful too. But finding a framework and using one is really good. So it may seem obvious to promote developers to security roles, but there are a couple of challenges with this. The first one is a accomplished security or accomplished software engineer is going to be paid more a little bit than a entry-level security position usually pays. So that has to be taken into consideration. And then the other thing is that if they're an experienced software engineer, they've spent a lot of time building, and sometimes switching over to the breaking side really isn't something that they're interested in, or even going from building to testing. So that raises the question, how do you get software engineering experience onto the security side? Well, enter the software engineer in security. Excuse me. So you've heard of the agile role of software engineer and test. This is similar to that. So this is a role where a person still contributes to code, but they're encouraged to spend more time in code review and those merge requests to keep looking at code with security concerns. And also they're encouraged to and enabled to keep up on security happenings, especially as it applies to their current platform that they're developing with. So one important thing here is that they would not bear the whole burden of security and software engineering, but they would be trained to understand and share security best practices. A lot of this, again, is happening through the merge request. So the merge request is all important. So you might be asking yourself, is this a security champion? And the short answer is no. This is a job title and a position. It's not a volunteer role. So if you were in one of the talks earlier about that talked about security champions, this is different. It's more specific. It's more, I feel, more professional and more effective in a lot of cases. Don't get me wrong, security champions programs at some places work really well, but this can even be used to augment that. This is really security embedded. So what are some of the foundational practices, some of those things that software engineers should know to create secure software? Well, as we talked about before, the merge request is very important, and so code review is really important. Doing this in a highly productive manner is very difficult. Being able to give positive feedback without triggering defensive people, without causing people to be defensive, is some of an art form, and understanding like the context of it so you yourself don't get defensive. But security obviously isn't the only part of this ritual, but identifying vulnerability and then talking about it in security terms is actually really beneficial, because then that informs us as AppSec engineers, so we can understand better what's going on. So that's very useful. Then defensive coding. I think this is something to key in on, because there's lots of defensive coding training out there, and all of it has value when it comes to security. So Wikipedia defines defensive coding as Coding, defensive coding is intended to ensure the continuing function of a piece of software under unforeseen circumstances. It focuses on things like code comprehension, code quality, and predictability of code. And it goes to reason that this would also be the basis for things like fail secure, exception handling, and things like unit testing, defense in depth. And so this can be a simple training that could be very beneficial to you at your organization. Input interaction modeling is understanding input data, what it is, how it's being used, and then being deliberate about the implementation of the use. And so we know there's a lot of vulnerabilities that come from that, from just simple input handling. Dependency management, of course, is a huge subject that could be a talk on its own. Most of the public package feeds are full of level 0 finish code, and developers contribute to those feeds not intending to support your medical device or your fintech app. And so developers need to be very cognizant of the dependencies that they're using. They need to know how to pick a library, they need to understand when to build and when it makes sense to fork, because it does sometimes. Implicit requirements are all the unspoken requirements. Sometimes you'll get requirements that require authentication, but they don't say anything about it. And sometimes a requirement also requires the opposite to be true. So understanding those things and just having the language to talk about it is very useful. Logging, of course, can be detrimental and very helpful. So covering that is important. Secrets management, having a way to keep your secrets out of your commit history is very important, especially when you're talking about protecting your supply chain, or you as the supply chain too. Modern auth flows can get pretty complex. Understanding the formats and things is really important to cover. Least privilege and session management along with that. Trust boundaries is something that a lot of developers are able to just ignore, and so we want to make sure that they get that training so they understand when a browser can be trusted and when that trust ends, as well as useful things like HTTP, where headers and cookies come from and go. And then standards and conventions play directly into code comprehension, so they help there. Then secure CI/CD, so having those pipelines secured really depends on the developers a lot, and secrets management too. But having them on board doesn't really take more time, they just need to be cognizant. You may be disappointed too in knowing how many of your developers don't understand the difference between encryption and encoding, because it just never comes up for some of them. So whenever selecting training, a key way to get buy-in from the developers is to include them in the decision. Maybe get a software engineer to actually take the test for you and really dive down into the content, make sure it's spending enough time on the things that make a difference. The majority of the training very definitely shouldn't be spent on any sort of breach training or pen tester training or exploit demonstration. It really should get down to the software engineering tax. There are several major training players out there that have really bad review questions. So that's something that I like to key in on is those review questions, making sure that they're asking about the material instead of just asking questions about quirks in the presentation. So they're trying to make sure that you watched the video or read the document. And a subject matter expert should be able to pass all the questions without even using the content. So here's the big takeaway really is don't spend money or time trying to change the way developers think, trying to make them a hacker. Instead, help them to hone their craftsmanship. Give them the tooling and the training to address the fundamentals to build a foundation for a robust software development lifecycle. And then address security concerns with software engineering tactics. Because a secure software development lifecycle will never outpace the underlying implementation, the underlying process, because the best way is for developers to code secure without becoming hackers. And I will stick around if anyone has questions on the sides of the stage. I'd love to hear any of your comments. Unfortunately, I'm out of time.
Test, 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 test. Yeah. Hello. Oh, I got so much technology here. Okay, let me just. Hey, good morning, everybody. Welcome. Come on in, sit down, sit back, relax, hang on. I just had a Snickers and a Mountain Dew, and I'm ready to rock and roll. Hopefully, you're here with me. All right. Hey, I'm Sean Groff. I'm with something called the SIZA. Anybody ever heard of SIZA? Woo! I don't have any dragon pants on today, but I'll try to channel the director as much as I can. She's awesome, our director, Jenny Easterly. So that's the Cybersecurity and Infrastructure Security Agency. But I'm not going to say that again. I'm just going to say SIZA because that's a lot to say. So I'm the regional director for Region 8, includes 6 states, including Utah. And I'm going to talk to you a little bit about our agency, just kind of where we came from, where we are, a little bit about the threat landscape. I've only got 30 minutes. This afternoon after lunch, somebody much better looking and smarter than me, Rick Gardner, one of our cybersecurity advisors, is going to talk for an hour about all the free stuff that you can get from us. A lot of free services that we provide. They're kind of prepaid. I don't know if anybody here pays taxes, but that pays my salary, which means it's a prepaid service. But a lot of really good stuff that we provide. Where's my little clicker? And I wish, anybody do Peloton? I feel like a Peloton instructor with this thing. They got the little, I didn't get my ride in this morning. All right, so a little bit about SIZA. So we were kind of born, we're really one of the newest federal agencies. We're part of the Department of Homeland Security, but we were born out of an organization that was stood up back really in 2003, 2004 when the department stood up looking at critical infrastructure. were something called infrastructure protection. And back then, we were just really looking at terrorists flying planes into buildings again or blowing up critical infrastructure, really the kinetic physical threat. But as the years progressed and we started, continued to visit infrastructure sites, they started talking about passwords and OT systems and IT systems, and the threat really started to change over the years, and cyber became a big thing. When I first started doing this, nobody talked cyber. So we had to change and morph. All of those things we used to do on the physical side, the assessments, the training, the exercises, those things, we still do those. We never let those go because that threat is still out there. It's a little bit different now, more so from internal domestic violent extremists and criminals, less so from the international folks. So that's still there, but we now have the overlaid cyber threat that we're very concerned about. But we talk about leading the national effort to understand and reduce risk to the critical infrastructure, both cyber and physical. And really a lot of that is just connecting stakeholders in government and industry across the country with resources, capabilities, each other, information, intelligence, all of those kind of things. If you look over there on I guess it's the left side of the screen for you, you see how we kind of break down infrastructure. So we break it down into 16 different sectors. It's just a way to categorize and organize sort of at the national level what we do. You can see our mission and vision there. I think that would be very, very clear to all of you. So just to get an idea of the audience, private sector folks, raise your hand. Awesome, love you. Any federal folks? Sit in the back, please. Just kidding. State, local government? All right, good. Good cross-sector of folks. Appreciate that. Our priorities, I think, hopefully these should ring true with you. Critical infrastructure, security, and resilience. That's kind of very broad. Again, that's our foundation, is looking at the security of critical infrastructure. Industrial control systems, focused really on cybersecurity. We do a lot of work with ICS systems. We have training programs around that Rick might be able to hit later on today that you would probably be interested in. Soft target security. When we first started looking at infrastructure, we looked at really things like water and communications and transportation, the hard infrastructure. But as the threat changed and people started going to malls and shooting people and schools and houses of worship and open air venues, we really had to change as well. That became a sector of critical infrastructure for us. So we go to houses of worship, we go to schools, we do physical security assessments there, we go to large events, think Cheyenne Frontier Days. Anybody know what Cheyenne Frontier Days is? That is awesome if you've never been there. It's pretty awesome. But we work with soft targets as well. Climate resilience, impacts of climate change, extreme weather on critical infrastructure, very important out here in the West. With the drought and the extreme weather, wildfires, we look at those things. In terms of federal cybersecurity, we have authorities over the federal.gov network, so that's really in the executive branch of the federal government. And then when it comes to large-scale incidents at the federal level, we lead what's called the asset response. So there was something very boring that you might think is boring called PPD 41, talked about how the federal government would respond to incidents, and we got the responsibility to focus on the asset. FBI does law enforcement, OD&I does the intelligence aspect, but we're focused on the actual asset. And then partnerships. We can't do any of this alone, so I've got 3 people now in the entire state of Utah to work for cybersecurity for CISA. It's a pretty big state for 3 people. So one of Rick's primary jobs is to work with all of you, partner with you, provide you our resources, get information back from you, all that sharing. So I think one of the unique things about CISA is our reliance on those partnerships, working with private sector and all levels of government. And it's fun. It's probably one of the most fun places to work in the federal government. Just a little bit about that. I mentioned Region 8, so I'm based in Lakewood, Colorado. That's just west of Denver. I've got a regional staff there, but I have people in all 6 of those states, kind of a similar laydown. I've got cybersecurity advisors. If you're looking for physical security, I have physical security advisors. I have chemical security inspectors and people who work communications, emergency communications. So if you're in any one of those areas, you may be interested in connecting. Services. I'm just going to hit this briefly because I want you to come back at 1:30 and listen to Rick. talk about in detail about the assessments and other things we provide. But vulnerability assessments, again, physical and cybersecurity advisors, they'll come in, they'll take a look at your facility, they'll analyze the potential threats, vulnerabilities, talk you through some of your security measures, security plans. You know, you could be very immature to very mature, and we've got a capability to do those. That's kind of the bread and butter of what our security advisors do. We also offer a lot of exercises and a lot of training. We do a lot of them virtually. So we do, I think, 4 or 5 webinars every month that are open to anybody, whether it's, you know, we've done insider threat, we've done active shooter, we do, you name it, we've done it any one of our pieces, and you can get signed up. You'll have contact information here. You can get signed up for any of those things. I mentioned outreach and information sharing. So we do a lot of outreach, events like this, webinars I mentioned, conferences, and then the information sharing piece, connecting you to various pieces of information. If you're on our distribution list for CISA, you get a ton of stuff from us. We send out a lot of stuff, and we're working through how to improve that process. But you know, you might have gotten 3 or 4 emails just this morning on different things that are happening. It's really important, I think, if you're in this business to be on our distribution list, to get we put out known vulnerabilities. We're not focused on one type of system or asset. We're looking across the entire industry and really trying to inform you on the most critical things that are happening every day, unfortunately. Direct technical assistance, that's just like it sounds. Incident support operations, so if you're familiar with the National Response Framework, we do what's called Emergency Support Function 2 at the federal level, which is communications, and 14, which is the cross-sector business and infrastructure. So again, bringing the private sector and critical infrastructure into a national or regional incident response. And then special events. I mentioned things like Cheyenne Frontier Days, but we also support things like the presidential inauguration or conventions. Super Bowls. We send people out before the Super Bowls, during the Super Bowls, do security assessments, both on the physical and cyber side and communications. So really there's no problem that we're not interested in or sector that we're not interested in. I want Rick to stand up real quick just in case you have too much lunch and can't come back. Rick is my cybersecurity advisor here in the great state of Utah, and come visit him if you're not going to come back at 1:30. He will be able to connect you with what you need. All right, so put this in here so that you have the contact information of my team. Andre Mouton got an extra S in his email address. If you're really paying attention, you saw that. I don't know, it's not supposed to be there, so just ignore it. And then here's some additional contact information. Okay, cyber threat landscape. None of this is going to be, I hope, a big surprise to you. I just want to take a drink, and then I want to tell you about, you know, so we put out this Shields Up message before Russia invaded Ukraine. I think anybody remember looking at our Shields Up? We're like, seriously, folks, get your shields up. We haven't seen a lot of the attacks that we thought we might see. That doesn't mean the threat's not still there. It's not still as significant. If you've seen what's been going on in Russia and Ukraine, Russia's not having a great deal of success that they thought they were going to have. So you might think that they might get more desperate. Right? So we don't know what the future may hold with Russia and what they may try to do in the United States, but obviously we're still concerned about the potential for them to launch cyber attacks into the United States, both from their state-sponsored assets and then cyber criminal groups that are aligned with Russia. You've seen the increase in ransomware attacks. They're getting more destructive. They're getting more prevalent. I got hit up about, you know, attacks on the federal government, and I said it's not just the federal government. Everybody from mom and pop shops all the way up to Fortune 100 companies are getting attacked on a regular basis. So we all need to have our shields up, and it all starts with, you know, with the individual. We know that other nation-state adversaries are investing significantly in their cyber offensive capabilities and defensive capabilities. Hacking tools, I mean, any of one of you, I'm sure, could get online and very easily find ransomware as a service. Anybody with basic capabilities can get on and buy their own ransomware. So they're just becoming more prevalent, more easy to use. We're working, as I mentioned, across the federal government, state, local governments to try to address that threat. But again, it's that collaboration. It's that information sharing. So it's very different, from the physical aspects of threats, that an incident or a cyber attack that happens at a small mom and pop water facility could have national consequences because of the threat actor and because of the vector and because of the malware that's being used, right? So that may be a test, and it's very quickly going to spread across the country to something more significant. So we want to know about those things, and I'm going to give you an email address that we want you to report those things to. And we may not come back to you and say, hey, thanks for your report. Great, here's what we're doing with it, because we get a lot of them. But know that the big gonculator back in Washington, D.C., we're assessing, we're analyzing, we're trying to make a determination of whether or not that's something that the federal government needs to be getting involved in, and then get information out to all of you in the community to take action. This is hard, turning pages and flipping slides and everything else. Why can't you flip my slides for me? I mean, what? No, just kidding, Rick. All right, so I want to talk a little bit about some of the things that we're offering that are kind of new to help out. One of them is the Cybersecurity Grant Program for state, local, tribal, territorial governments. First of its kind, just came out. We just came out with a notice of funding opportunity, I guess a month ago, 2 months ago. It's closing in November, but state governments can apply for cybersecurity grants. It's run similar to the way the FEMA grants are run, if you're familiar with that. There's an application process that is open and closes on November 15th. So if you're part of state government or local government, hopefully you've heard of this. If you haven't, again, reach out to me, reach out to Rick. We'll get you connected, get you as much information as you can, but you can Google Cybersecurity Grant Program and find a lot of stuff. First year, we're really looking at basic capabilities, getting folks to establish a cybersecurity plan, do some assessments, get a really good baseline, and there's going to be 3 more years following this of funding from the federal government for cybersecurity. I think it's 80%, Rick, has to go to local governments, which is really great because we know there's a significant deficit in resource capabilities at the local governments. Think county, think city, and so they need it. They need the support and help. The other thing, Cybersecurity Awareness Month. So I know most of you are cybersecurity professionals in here, or hackers, or just people really interested. But Cybersecurity Awareness Month is every October. I think it's, what do my notes say, 19 years now we've been doing this thing, and it's really to raise cybersecurity awareness across the country. There's an awesome toolkit on there for your awareness programs, for your training programs. We put out, these basic slides. A lot of good resources on Cybersecurity Awareness Month. This year it's called See Yourself in Cyber. What we really want to do is to bring cyber all the way to the individual level, cybersecurity practices, right? So you're all practitioners, you're professionals, you know not to click on that email, you know to update your software, you know all that stuff. But we want grandma and grandpa to know the same thing. And we're kind of relying on all of you in this room to help us with that, because really, I think they said 90% of ransomware attacks start with a phishing email, whether they're successful or not. I don't know if the statistic is right. We get new ones all the time. But that's, grandma and grandpa sitting at the computer, or, your least trained employee sitting at the computer going, yeah, that looks right. Let me click on that. So this month is all about everyone being able to see themselves in cyber and promote cybersecurity. This is one where it really takes a village, right? It really takes the entire nation. I'm going to talk a little bit about some of the action steps, the basic action steps we're asking you to promote at the end here. I mentioned that report a cyber issue deal. This is very easy, CISA.gov. Report opens up a little email thing, and you can report your cyber incidents. Or just call Rick anytime, day or night, on the weekend. We won't even give them overtime. And this is the Cybersecurity Awareness website, so you'll have that to click on. Again, a ton of resources. Shouldn't be any malware on that site, but I'm not guaranteeing that. But go ahead and click on that link, and it'll get you to some free resources. Action steps. So these are pretty straightforward, but these are the 4 things that we think that if you promote to every individual across the country, will be much more secure as a nation. So multi-factor authentication, you know, you don't have to even say that word. Just say, hey, Ma, when they ask you if you want a text message, you got to do that. Got to do that thing. I got nailed on Facebook a couple of weeks ago with that and the text message thing. Somebody got my Facebook. I hate Facebook. I know. Look, I got the suit thing on. I know I use Facebook. I'm an old guy. Okay, tease me. All right, strong passwords. That, you know, complex. It's amazing how often we find that people are still using the password. I'm sure you could. Anybody else catch anybody recently with password 123 as a password? Yeah, when we first started doing the critical infrastructure stuff, the OT systems, people would still use capital P, the one it came with, right? Didn't change it for years. Anyway, strong passwords, recognize and report phishing, and then updating your software. I have a little mnemonic I'll share with you. It's not approved by CISA, but I'll share it with you because this isn't being recorded. It's just being live streamed, which is different. Right? Nobody would record. I say, make strong attacks fail badly. Make strong attacks fail bad. Make multi-factor authentication. Does anybody think this is cool or not? Come on, give me. I don't have a vampire costume on or not. Come on, I'm making stuff up here. Probably going to get fired. Make strong attacks fail badly. Multi-factor authentication, strong passwords, strong attacks, antivirus. So that's not in there, but I needed an A. Antivirus, fail with a PH, fail, right? Badly, backup. That's also not in there, but update your software is close enough. Make strong attacks fail badly. Good? Yes? Good? Thank you. All right, that's awesome. Thank you. You're very kind. You just want to go to lunch. I know. I get it. Okay, so that's thank you. No, I'm supposed to go to questions and answer. There's contact information. So it was great speaking with you all this morning. Remember that right after lunch, our cybersecurity advisor, I already told you, Rick's going to be here. He's going to have a ton of stuff for you, a ton of opportunities to partner with each other and partner with us. What questions? You can't leave yet. Where are you going? Any questions for me? Got to be one. Sir.
How do you see the cybersecurity kind of growing and developing over the coming years? What do you see happening?
I could not hear that question at all. I apologize. Did you say, how do we see it changing or developing?
Yeah, what growth do you see there, improvements? How do you see the long range for the cybersecurity?
Well, what I have seen, so I've been part of the department since I left the Army in 2003. I think what I have seen is a significant improvement in the information sharing piece, and not just in the federal government, but across the industry. We're partnering with companies, you know, the big tech companies like we never did before. So I see that as a significant improvement, but I also see things like the malware being available free on the web for any any individual to download and utilize, and that's just going to continue. Tying sort of the cybersecurity piece to the overall threat picture that we're looking with misinformation, disinformation, I just see a proliferation of again, bad actors continuing to use our own freedoms against us on the web, on our social media platforms, and doing things like, you know, the big fakes, those kind of things. So yeah, I mean, it's unfortunately going to continue to go this way, but I see that our sharing, our communication, the things we're providing is going to increase as well. Hopefully that kind of helps. Sir.
You mentioned that you're interested in many, there's like no areas you're not interested in. How does CISA define critical infrastructure?
Yeah, so the definition of critical infrastructure is in something called the National Infrastructure Protection Plan, and it's really defined as those assets and systems so vital to the United States that their destruction or incapacity would impact our way of life. So that's all the really big stuff. One of the challenges we have, again, if you think of the cyber threat versus the kinetic threat, is that may not be a critical infrastructure, but that's a critical attack, right? So that's a critical vector, that is a critical piece of malware that now I need to be very interested in. The other piece that I think we weren't thinking about in 2003, 2004 is the way of life part. I have little kids that go to elementary and junior high school, and I pray every morning when I take them to school that they're not going to get hurt. And I don't mean like fall off the playground. Anybody with kids, we never had to think about that. To me, that's way of life. That's now critical infrastructure. And so the challenge for us is, what's not critical? We do prioritize, those lifeline infrastructure, especially on the physical assessment side. We prioritize those that are going to impact the most people, but we essentially have to kind of look at all of the things that are going to impact our way of life. Go ahead.
And then I guess follow-up is you offer all these various services. You don't charge for this? Is this all like...
You already paid for it every year by April 21st. Appreciate that. Yeah, no charge. No charge, but I will tell you that we have some things that have a significant backlog in terms of requests that require maybe national level assets to come. And then we have other things. We have lots of self-serve capability, self-assessments and quick assessments. So, and that's where the human being can help you sort of determine, where you fit into that picture and how we can get you those services. I thought there was another one in the middle. No? Way back there. Oh, this is going to be hard to hear.
Which nation state poses the biggest threat to our critical infrastructure?
Whichever one is attacking us right now. They're all, I think it's been very, the ODNI puts out a national threat assessment every year. This last one, and it's unclassified, like anybody can read it. This last one had so much information, I was shocked. We would have classified that in 2004 like TS-SCI with 48 different caveats. It's totally unclassified, and they really do a good job of walking through the capabilities and intent of the nation-state actors, and they do it from sort of the kinetic national level side and the cyber side. So I would encourage you to look at that, because that'll give you more detail about where we think each one of them are. Way back there, I see the arm. I don't see the face.
First off, thank you for coming and talking here today. But I wanted to ask you, there have been some people in government positions who have left saying that we do not have, or they did not have enough support to compete against actors like China, Russia. In your personal opinion or professional, however you want to say it,
I'm not allowed to have a personal opinion, but go ahead.
do you feel like you're getting enough support and to do the job that you believe that you need to do for your mission of security for our infrastructure?
I'll Yeah, so elections falls under the government facility sector. It's a subsector under that, which is why you don't see it up there. Yeah, we work with the elections offices very closely. They have, they avail themselves of a lot of our resources. In terms of recommendations for you working with them, now if you don't already have a relationship, right now is kind of a bad time to reach out because they're busy, but after the election is over and things have been tabulated and argued about, I mean, it's just making that connection. assessing what their needs might be, and whatever you have in terms of sharing information. I mean, elections, again, are the cornerstone of our democracy, and you know, we all have a role to play in that. So that would be my initial recommendation to you. Yes, sir.
Let's say you come help assess our security. If you find one of my employees not wearing a badge, can you cancel all my federal contracts?
I don't have the authority to cancel your federal contract, sir. Now, our assessments are voluntary, and on the cyber side, with what Rick does, we're not a regulatory agency. We have a small regulatory function within CISA. It's related to the physical security of chemicals. But yeah, we're not a regulatory agency from that perspective, and we provide you options for consideration, which one might be have your guys wear their badge. Might be a good idea. So yeah, I'm not planning to cancel any of your stuff. So, yes, sir. Oh, I'm sorry, you have to wait. Okay, you in the back that was waving. Okay, you, sir.
So, as I understand it, I've always heard it said, when you compare, let's say, on the national level, on the cyber front, that America always had a greater offensive capability and we have defensive capability compared to other nation states. Is that true, or how are we going to measure up on that?
I wouldn't know. I'm not involved in cyber offensive operations. That's a different part of the government. So I wouldn't be able to provide a good assessment of that. I could guess. What's that?
How would our defense
Compared
compare to their defense?
to other nation states? I mean, I'm not really willing to make a comparison. Anybody else?
Russia's been known to take down Ukraine's power grids. Does the U.S. Are our power grids up to date, and do we have the capability to have the manual controls in place, or to protect against attacks like that?
I think I would answer that to say I think our power grid is pretty resilient, and we've seen that based on a lot of natural disasters, not even, considering cyber attacks, with the multiple different grids we have. So I think it's just a much different situation in terms of the physical grid than they have in Ukraine. And I think I have time for one more question, and then everybody's going to lunch. I know I answered 2 years, so if there's nobody else. Okay, you get it. You get the last one.
So sometimes there's a worry about any kind of like governmental agency, how effective they will be at their job. And I guess I'm wondering, do you guys receive enough funding that you're able to like hire like the best of the best to perform your duties?
I think that we're in the same position a lot of companies are in terms of hiring cyber professionals. There's a significant gap in the number of in the cyber workforce, and so we face the same issues. We've just gotten a new hiring system for hiring cyber professionals called the Cyber Talent Management System, which sort of opens up our ability and flexibility within the federal government. It's still not as flexible as industry, so you might say we're competing, but I think most of my cybersecurity advisors could probably leave tomorrow for a significant increase in pay, but the mission is so important, and a lot of them are ex-military, et cetera, and they really believe in wrapping themselves in the American flag and protecting the country. I mean, that's why I've been doing this as long as I have. So, yeah. Okay. Well, thanks everybody for hanging in. Appreciate it.
Close your eyes. It's time to discover what starting and growing your own business feels like. Whether your business is bed sheets or skincare, Shopify's with you every step of the way. Now, open your eyes. This is Possibility, powered by Shopify. Sign up for a free trial at shopify.com/listen22. Shopify.com/listen22.
Test, 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 test. Thanks, sir. Okay. So I'll hang tight and you'll tell me when to roll. And the light is green too. I always mess these things up. I've barely done a lot of these. Oh, like this. What are you doing? How are you? Slut. We got a little spot on the agenda. Yeah. Oh, don't do that. No heckling. Yeah, these are my guys. Yeah. I like it a lot. I've really liked my school. It's new for you. Doesn't mean I get to retire, but I've secured those pensions. I'm going to be the W-5 over Signal War Officer, so kind of the branch chief, Signal branch. Yeah. Maybe come over to the Army side. I'm getting ready to talk, so good to see you. We're good? Okay, I'm going to get started. So thanks for coming back from lunch to kind of round 2 of this. So I'm assuming most of you were at the presentation here at 11:30, where it was our regional director kind of gave an overview of CISA. And so I'm going to assume some of that. In this presentation, I'm going to go really quick. I put a ton of slides into this. It's not all about, it's cybersecurity resources, okay? So that's what we had entitled this. My name's Rick Gardner, I'm with CISA, and I'm the Utah Cybersecurity Advisor. So I'm gonna try to give you the nuts and bolts of cybersecurity resources that we provide, but I've got a lot of additional training resources. At one point, we've got the Utah SIAC that I just want them to stand up, and I'm going to I have a slide in here for them. We're going to talk about the grant, some of the monies that are coming out of CISA to improve cybersecurity resilience across state, local areas, but just a lot of slides. So I'm going to go quick, and really the intent is to give you an overview. But if you need to follow up with me and you want more information, just send me an email, and so I can send most of the stuff I'm going to present and do a deeper dive with you if you're interested in some of our services or you need more information. Real quick about myself, I'm 4 years in now as a cybersecurity advisor with CISA. I was their number 11th hire, and we're at about 60 plus cybersecurity advisors at this point. And so this agency is growing really rapidly, and it's been really fun to be part of all that. And I used to have to cover 6 states and then 3, and now I've just got Utah. And so just having a blast doing it, and I appreciate you guys coming out. I'm also in the military, so I'm dual-hatted, so I'm still in the military. I've got 28 years. My last 10 have been on a defensive cyber operations team. Some of our guys are here, and they're trying to mess around with their flipper and turn my TV off. I quit it. Anyways, just a ton of fun on the military side, too. Okay, so with that, again, CISA is really, the mission for us is to improve resilience and maturity in critical infrastructure. So a lot of ways that we're going about doing that, and that's embedded throughout my presentation. So today we're focused on cybersecurity, but there's a lot of other types of people that are across the board working our mission, okay? And that's overall resilience and maturity. We specifically work with state, local, tribal, territorial, and we hit the 16 sectors. So we're broad, right? And if you've got questions, save them for the end. I'll try to give you some time at the end for questions, but this is where it gets to me a little complicated. It's who do we offer all of our no-cost voluntary resources for? We're focused on critical infrastructure. That's our goal. That's the mission vision, and it's where my priorities are. But at the end of the day, there's a lot of dependencies and support that critical infrastructure needs to overall provide their critical services, right? So it gets a little complicated. What we do primarily results in reports, right? So when I come in and do an assessment, you do a pen test, we have this program that really enables us as a federal government agency to work with the stakeholders we work with, so all 16 sectors, right? It's PCII. So when we give you our reports, they go back through this program, PCII. Because you're part of critical infrastructure, it protects the report from GRAMA, from FOIA, and from civil litigation. So there's a lot of value in that. So if you're a CISO and at the end of the day you're voluntarily asking for a risk assessment, there's no attribution in where this is going. You can't be FOIA'd. It's for you. It's to enable you. It's to highlight your overall cybersecurity posture, your risk areas, and it doesn't go anywhere. So very valuable program, and it's really what enables us to come on site and have a pretty transparent assessment on where you're at, right? So lots of details. I'm going to continue. Again, I kind of highlighted this, but there's a CSA and a cybersecurity coordinator, CSC, for almost every state at this point. So Utah is still, in fact, our CSC is out for bid now, and so that'll be a position we'll fill here shortly. But we're really booming across the nation, so they're working rapidly. If you heard our regional director, he said he's got 3 times the amount of funding this year than he did last year to grow our regional capacity. So it's pretty neat to be part of all that and to see more effectively, work with you guys and give you some of the assessments and the stuff you're volunteering for. So this is me. I'm a cybersecurity advisor, and these are the things I'm really here to do. So I'm available in a lot of different capacities. I primarily provide on-site cybersecurity assessments. However, I do workshops. I'm a collaborator, right? I work with a lot of different agencies, and at the end of the day, there's quite a bit that I can provide. I'm a pretty useful guy. So these are a lot of the things that I do. So when you think of CISA and you're thinking cybersecurity resources, there's a lot of them. And so what you typically do is you start with me, and I work with you on kind of a strategic approach in what where you're at. So we call it a cyber protective visit, and what you're ready for. So I don't typically promote and offer a pen test right off the bat. I want to first help you to understand your overall cybersecurity posture, and we go from there. But we do a lot of stuff, but it's kind of a strategic approach. So you're not needing to guess, well, what's an RVA, and am I ready for that? That's more of a validation assessment. That's something that comes at the end after you've kind of gone through, what is your posture? We get some phishing campaigns, we get some scans, you're building maturity, we're assessing that maturity, and then on to the next. When you think of cybersecurity, it's reoccurring, right? It's not something we do once, it's not a one and done. This should be on a cyclic type reoccurring repeatable basis that never really ends. And we have a lot of things we can do to keep you busy, basically. So this is where I start. So as a CSA, I can't necessarily, it's not smart really to go right towards a validation pen test. I start with the CRR. So this is 6 hours. It's me on site with you, going through a series of about 360 questions, okay? So this is a tool that Carnegie Mellon University helped to develop. It's based off the NIST cybersecurity framework, and it's done pretty well. So again, no cost, voluntary, based off the CSF to include the CERT RMM, or the risk management model. It's going to look at your cybersecurity posture. You're going to get a report. The report's about 120 pages, and we're looking at these 10 domains. Okay, so we're starting with, what do you have? Asset inventory. We're going to grow from there, and you can see we'll look back then to how is your stuff configured? What are your controls? What capabilities do you have? We specifically look at people, technology, information, and the facility. So we're looking at those 4 areas across these 10 domains. So it's pretty, when you think of what is your cybersecurity posture, it's pretty broad, and this report helps for you to really better understand what your posture is. And then it's going to give you maturity indicator level, MIL, 1 through 5. So if you have 3 people and you're providing, you're the IT staff, you're responsible for security, it's going to look for, my question base is going to be based on what do you have, and is there overarching policy, SOP, is there repeatability to what you're doing? And then ultimately going into, is there management oversight to ensure that, for instance, when you're, changing an access control list on a firewall or a group policy on a server, is it being tracked? Is it being done in accordance with policy? And then we get into the measurement pieces. Where is it effective? Did it have its intended effect? Did it work? Is there any analytics dashboards associated with that validation, right? So that's how we kind of get from MIL 1 to 5, and that'll all be indicated on that 120-page report. So lots to that report to include graphs, charts, green, amber, reds. At the end of the day, it's going to give you here is your overarching posture. Here's what you're doing well, green. Here's what's a work in progress and or is maybe tribal knowledge. It's not completely repeatable. And then finally the reds of here's where we have vulnerabilities. These are your opportunities for improvement. Again, because this is all non-regulatory, it's just based on framework approach. you do with this report what you want, right? At the end of the day, it can do you a lot of good as far as it helps to formulate a risk register, right? If I asked you, for your network, what is your cybersecurity posture? Would you kind of know that? What are the top 10 risk areas? Would you know that? This helps to form that. Do you have a risk register for your network security, right? So this helps to get that initial approach to here's where we're at, here's some options for consideration on how to improve. So it's pretty valuable. Again, 6 hours, that's me on site with you. I'm out about 3 months. Just keep that in mind. I'm always out about 3 months. And I think it's going to get worse before it gets better, but I get 2 new hires, like has been talked to. So it'll get better here soon, but right now I'm out a little ways. Okay, from there, it's the second assessment, again, strategic approach. We want to extend your posture to external dependencies, supply chain, right? Vendors, third parties. So when we have and look at our external dependencies, have we applied the same controls? We have the same, repeatability and maturity on our own networks, right? As when we bring in a third party, have we applied those same controls? Do we have, your boilerplate contract language? Does it include those controls with our supply chain? So many times we're compromised, right, and or vulnerabilities exist from the outside, those that are connecting in, helping us. And so that's what this one's going to give for you. So again, voluntary, this is about 2 hours. And if you kind of don't have real mature checklist at what should we consider for ensuring our vendor has, so for instance, are they patching their systems? We require that. We have confidentiality, integrity, availability requirements for our own network. Have we ensured or passed along those same controls to the vendors? If you don't have any foreign components in use by policy on your network, then have we applied that same control on theirs? Or are they coming in with, foreign components? They're going to create big vulnerabilities for us. So it's just putting those things over. So again, too easy to help you do this. This is about 2 hours, and you'll come out of that with a lot of, again, it's suggestions, it's opportunities to strengthen, improve your relationship with the external third-party vendors, right? The third thing I do that I really like this, and I think there's a lot of value in this. So after I've left you with here's where you're at, here's what we've looked at with the vendor, it's a dashboard. So as you're continuing to make improvements, as you're creating priorities, you're adding controls, you're writing policies, things are improving. If you record those in this dashboard that I come on site to help you build, it can do a lot for you. So the way this is kind of done, it's just kind of like the CRRs based on the NIST cybersecurity framework. We have the same domains we're going to look at, okay? And then you're going to have this formulated dashboard. So this serves as a couple cool things. One, it helps to document, like put on, a dashboard your overall posture, your portfolio. These are the applications I'm using. This is something that you can now hand off to somebody, right? Because that's another risk is that, you've done all this work, you're a WAN manager, and you've been here for 10 years, and now I'm going to go work for NICE, right? So, well, what'd you leave behind? Can your predecessor pick up, understand, kind of where you left off? This helps to do that, okay? So once it's created, there's a lot of things I love about this. So kind of check out the screen on this. So it will compare you to others in your same sector. So when we talk about these framework approaches to going after our cybersecurity, improving cybersecurity, we don't all have unlimited budgets, right? We're not all trying to, build Fort Knox, but we are trying to, understand our posture and make, investments wisely, right? This is going to show you how you compare to others in your same sector. So I feel like there's a lot of value in that. If you're a water system, you shouldn't be compared to, a bank. It's going to compare you to others in your same sector. As you make improvements and you use the dashboard to track your improvement. So let's say you weren't restricting any removable media. You got that, accepted into the business. You create that group policy. It's applied. It's restricted. You identify that. You mark that on the dashboard. It's going to show that improvement. Okay, your posture will change live on the spot. You'll be able to see the improvements in multiple areas, because that actually is a really good one to go after. But you're going to be able to run management reports. So you're doing all these changes, all these improvements throughout the course of, let's say, a year, and now you need to show a return on investment, right? Hey, we've given you this $400,000 or whatever, right? Where have you invested it? What has it done for our business? This is a way that it kind of helps to quantify that return on investment. That's always a hard thing to do when you're basically mitigating risk, right? This kind of changes some of that. So you can run management reports. The scenarios are awesome too. I'd use my little red clicker, but you can't see it, so it wouldn't do you guys any good. But it lets you run threat scenarios. So again, too, as you've created, this is what I have. Let's say you're not backing up your data off-site. You're going to answer it that way. And then when it runs a natural disaster scenario where your primary site is taken out, it's going to show you how well you have that continuity. And so once you've identified that, those threat scenarios help to put in the this is in life without that control. This is what's going to happen. Same with like a denial of service attack, ransomware. They're doing a lot in this dashboard to improve it too, just so it continues to be relevant and gives you back what you need. So this one is about 4 hours, me on site with you guys too. Okay, from there, I'm moving into more of the technical offerings. Again, I'm focusing right now just kind of on the CISA stuff. So you heard, I think, Sean speak to, we're pretty big and growing. There's about 1,000, I think, now that are all within CISA. We're division, we have regions, a lot of us forward deployed. I'm right now the only one in Utah, but I go back to, 30 plus or so in Colorado, and then back to 800 or so at headquarters. We have a lot of stuff, and so I can make sure that you understand better all the things, and that you're engaging smartly and getting what you want out of us. And I have other teams that help to do those things too. Okay, so I'm just the tip of the spear. So I'm just re-emphasizing that. So this is something we do really well. So we have an exercise team that does, you name the scenario. A lot of times, if you've never tested your incident response plan, that's a really good opportunity. So this team, they do this for 16 sectors across the nation. They're really good at it. You only have to sit through about 4 meetings. So these guys are going to ultimately help to understand, what do you want? Literally, what's your end state? What do you want to have as a result of this exercise? And then they formulate the injects, the strategy, so you get what you want at the end of typically a 4-hour exercise. So 4 hours of planning, we formulate it, and then we come out on site and or remotely, and we help to run it. So pretty fun. They do a really good job. And if you're really struggling with, look, I'm in IT security, and no one really understands what it's going to be like to go through, let's say, a ransomware event. That's a great opportunity to, let's create some transparency, inviting the right people in the same room, going through those injects where they get to kind of feel like, hey, how's this hospital gonna run when we don't have, access to patient records? Are we shutting our doors down? Are we accepting patients? How's this gonna continue to run, right? So these guys do a good job. Think of where you work, and if you've ever done anything like that, In the military, we do this all day long, where it's like there's too many of them, but they're fun, and you can get a lot out of it. So anyways, we do that really well, okay? This is one of the teams we have, so they do malware analysis. So if you get hit with something and you're not sure what it is, send it in. We'll help for you to understand. Let's say, again, I'm going back to malware. It's what's really rampant out there right now, but you're not sure maybe the variant of ransomware you're dealing with. We help to you to understand that, and we usually have a whole lot that we're going to give you back to help you navigate through what you're dealing with, right? So this is on my network, you know, how to kind of eradicate it, what you're dealing with, so white papers. So they've done a really good job at that. Okay, I put this slide right here because I'm telling you, we do all this stuff, right? Well, we're young as an agency, we're growing, we're building, but here in the last, we're getting backlogged. Okay, so with elections, with a lot of the Russia-Ukraine stuff, the Schultz up stuff, we're really being sought after for a lot of these services, and we're getting backed up. Okay, so I put this here so you kind of understand. You're looking at remote pen testing, my RVA, my risk and vulnerability assessments. These things have wait times. Like that RVA, that's a big one. You're going to wait for every bit of, I'm going to say a whole year. In fact, we just had a group get one here that they waited 2 years for. So again, we're not that agency anymore. We're working towards effectiveness, right? But it's still, we're getting there. So again, that's my job, is to help you understand what you want, you know, what we offer. You kind of tell me what you want, and I create this is probably when you're going to get it. And we have opportunities to, hey, you know, this is big for us. When we're running, let's say, the playoffs here in Utah, really, is there nothing you can do? Well, actually, I have some trump cards that we can say, yeah, we're gonna get this. It's gonna be quick. I can do that in the region and for the state, but everything has a wait time. Okay. So, but in the meantime, while you're waiting, let's say, for that RVA that, you know, it's going to be a while, there's low-hanging things that we can get fast. Okay. So this is where anyone who works with us, we really promote, you got to get this, right? So this is the vulnerability scanning. This is Nessus. You're going to get a weekly report. For us, this is not hard to set up. We can get you these scans running very quickly, okay? And if you've worked Nessus at all, it takes tuning, right? So this isn't a tool that just works for everybody in the same way. It takes configuring and tuning. And at the end of the day, we're doing a pretty good job at it. And if you're having this done for you, let's say by a vendor, or this is something you run on your own, still would encourage you to validate your scans with ours, okay? So take advantage of that one. And by the way, the way to do these, right, to request this service, again, through me. Shoot me an email. I've got forms. You'll fill them out, ask for them. I'll encourage you to better understand. I need to better understand, well, who are you? Are you in critical infrastructure? And I help to prioritize some of that and get you what you want, okay? From there, again, this one's available to you, pretty highly available, but it's web application scanning. So most of our stakeholders that request the Nessus scans, the the vulnerability Sci-Hi scans, we add this right on there because it kind of goes hand in hand. This is external facing, right? So yeah, I should have clarified that. When we're not scanning internal devices, this is outward facing devices, okay? Same with web application scanning. So external facing devices, let us help you to ensure configuration of your web application is set up, you know, properly. There's no vulnerabilities, okay? Okay, this is another one that we do pretty good job at, phishing. So you've probably all been part of phishing campaigns. In fact, I'd say here in this, venue, you guys are the ones in charge of them most likely, but we do a good job at this. So has anybody received these from CISA in here and can help to validate or say, yeah, we do a good job? I mean, these guys are really crafting their stuff like we're seeing in the wild. And so the way this used to be done is it was 6 weeks and done. This is now ongoing. So when we set these up for you, They're done in kind of complexity layers, so 3 different ones. So it's kind of a build-up, mid, and then they get a little bit more complex, but we just keep them going until you guys really tell us to stop. You get back click rate reports so that, as IT, staff, you get a chance to do some more training and awareness, especially the clickers, right? They usually need a little bit more remediation training. But the more our people are on their toes, right, when they're at work and they're hesitating before they're clicking, that's kind of the environment we're trying to create, right? We're trying to give our users more, exposure to some of these tactics, techniques, and procedures being used against us. So highly recommend a phishing campaign. Again, all at no cost, okay? The vaders. So these vaders, they're awesome. These are really harder to get. I recommend these typically to industrial control systems, more complex type systems. But this is, again, a team of really, high-end, very smart guys. In fact, a lot of them I'm surprised with, they're from the cyber protection teams, DODs. So I've met a lot of these guys, but they do a great job at looking at your architecture. So how is it stood up? They actually do look at device configuration. They do traffic analysis, and they give you back, again, like I previously stated, reports on how to improve. Okay, so PCI protected reports, and I have worked with some big, I'm just going to, no attribution, but pipeline, an entity that brings in $6 billion a year, and they've paid for a ton of these, and they've said ours they're the best, they're the most usable, we've found the most. And so it's like just validation to me, who's out here, pushing some of this stuff, right, for your use, but they do a great job. So consider a Vader, specifically if you're with any type of industrial control type system, you have a kind of complex environment. These are a really good, again, no-cost service. Remote pen testing. So this is kind of obvious, right? But again, before we want to offer sort of, to me, this validation and pen tests, again, external facing devices, we're going to want to go through some of those other activities first. But we do pen testing. Again, they always, well, not always, but they'll typically find a way in. They're pretty good, actually. So again, I'm constantly kind of impressed with and it was asked in the last session about kind of the staff and who we have, and if they're how was the question, but I'm seeing some of these guys as the best and the brightest, honestly. They're the guys that could go on to make a heck of a lot more money, but quite honestly, they're really into the mission and doing some of this work for the nation. And I've met a lot of these guys, and they're good. So these RPTs, think about that one as a requesting from CISA. And this is the last one. So this is the most comprehensive. This is a 10-dayer. It's called the RVA, so it's Risk and Vulnerability Assessment. And this is going to give an organization an external pen test. It combines phishing. Again, these guys are going to probably end up in your network, but you're going to work with them as administrators so that, I get some things within the network are off limits. Sometimes the activity you're doing at a certain time in the day is off limits. So you'll work with us on the scope. We have agreement forms, so it's, hey, you want us to be there, you're volunteering for us to be here, and therefore, we're not responsible to, right? Because we're not, our stuff's, it's not hard knocking and pounding, it's not gonna take down your network. It's scans, it's validation of password complexity. They have a tool that they run to validate separation of duties, least privilege. It's really cool, some of the tools they use. They end up on site. So it's a week off-site. It results in a week on-site. And they'll be in your networks, and then you're going to get back these reports on all the areas that they, hey, we tested this and weren't able to get in. So validation to include, this is where we did get in, this is how. Maybe they pivoted from one system to another. This was a known vulnerability that we were able to exploit and get in. Good stuff. Really good job. I've only actually seen on site one of these here in Utah, just to be transparent. So again, my job as the Utah CSA is really to request, the world and let us deal with the problem of how are they going to deliver all this across Utah, right? But that's my kind of goal. But I want to manage expectations too. This is something you're probably not going to get for the first, it's going to take every bit of a year, most likely, and not everyone's going to get an RVA. That kind of goes on to, okay. So this is the resource hub. So Sean talked a lot about some of the stuff that's offered on this. So I'm going to go into a little more detail. So when you can see the URL there. CISA has a lot that they've done to try to really, it's situational awareness, it's training, it's alerts, bulletins. This is that one-stop kind of shop website to where if you want to receive alerts from CISA, this is where you go. You see that he brought up, if you want to report an incident, this is where you go. It's actually that yellow one. They've got all kinds of stuff, right? If you're interested in 5G and some of the, the things you should know there, concerns potentially, this is where you go. So it's the resource hub, okay? So I want to highlight that. This goes into a little more detail because everyone wants to kind of understand and receive typically alerts. This is how you do it. So back to that hub, you can see that red circle under resources, and then there's alerts. That's how you subscribe to CISA's alerts, okay? What else do I want to make you aware of? So you've heard, okay, it's this next slide. So we've done a really good job, I think, at, so when it comes to vulnerabilities, right, that then require these alerts, we have a known exploit, so we have a list of all the known exploited vulnerabilities, and they're prioritized, and they're reorganized, and they're added to and kept current constantly. In fact, I was in them last night, and they had just added to it. And so this is real vulnerabilities, but that are actively being exploited. And again, too, they're working, with a priority as far as, hey, if it's, for instance, let's say it's an advanced threat actor. Russia's actively doing this with these specific entities. That bulletins, that known exploited vulnerabilities can be right at the top. Versus, for instance, how do you rack and stack vulnerabilities if you're doing responsible for vulnerability management within your organization? Sometimes it's hard to go after it. They're not all created the same, right? So we've done a pretty good job at that. So this resource hub is a good place, and that's on there. That's a list of kind of how they look. Again, highlighting if you have an incident. Reporting incidents is a pretty big deal, right? There's a lot of ways that we go about this. So this is how you do it with us. So you can see on the slides, you can report phishing, report malware, vulnerabilities, indicators. Again, like Sean said, once we get this in, there's a lot of work that's going on to ultimately then create the alert, make sure that through the ISACs, the different sectors understand and get these alerts so it's getting to the right people. And so again, voluntary reporting at this point, but I got a slide. It's not always going to be voluntarily, right? So are you familiar with CERCIA? So this is what is it, an act? It's signed into law, okay? Just recent, so this is March. So basically, incidents are to be reported to CISA. However, they're still working on who needs to report what. So I only put this up here to just kind of give you that overall awareness of, when you go through an incident, it's important that it gets shared, it gets, reported for a lot of reasons, right? I mean, we learned a lot, and I'll just bring it up because it was on the news and stuff, so we really are pretty serious about no attribution. But, when a water system's, compromised in Florida, we all need to understand who did that? How did they do that? What do we need to do to ultimately mitigate that from happening to us, right? That's how it's being done. So a lot of collaboration, like Sean said again, too. We're not in this alone. We work a lot and heavily, closely with FBI through these ISACs, MS-ISAC, so that when something's reported, it's understood across the top, and actions can be taken to create awareness across, really the nation. So again, more to follow on this, because this is still being worked out. The magnitude of an incident, what has to be reported, right? Who has to report? But it's all part of CERCIA. So that's kind of where I want to leave this one. And I'm sure there's going to be questions on this, but they're probably not for me, because this is all still being developed, okay? So with that, that's a lead into these ISACs, okay? And so I'm assuming, especially in this group, you guys are familiar with information sharing and analysis centers. But if you're not, just be aware that this is how every sector ultimately you can subscribe to and receive information and communicate, threat intelligence, technical, again, advisories, bulletins that are created are pushed out, and we're creating kind of that broad situational awareness across the sectors. Okay, so I'm going to highlight a few things. So one, let's just do this now. So here in Utah, so we have a fusion center, right? We call ours the Utah SIAC. They are a state information and analysis center. So you guys mind standing up for a minute? So we have a bunch of members here. This is Utah SIAC, okay? These guys are working their butts off. And if you have questions here, so why I wanted them to stand is because you see them, and if you have questions after the brief, go talk with them, okay? Work with them. They're working their butts off to really keep us aware. Training opportunities, advisories. They're constantly, maturing this, finding efficiencies, new software. They just stood up. In fact, I'll hit this. I'll come back to that one. Well, you know what? While I'm here, MS-ISAC is probably one of the most mature ISACs. So if you aren't currently receiving awareness through any of the ISACs, consider the MS-ISAC. It's multi-state, but they put out a lot of stuff. It's hard sometimes to process it all, because literally it almost takes a person, and if you want to do this with some maturity, it takes a lot of effort, but we just can't be on our own. We need to share, and we need to learn from one another, and so we can harden ourselves against everything that's happening really across the nation, right? These ISACs are really pivotal. Utah does a heck of a job. So this is their site. So you can see SIAC at utah.gov. So they have, it's a Whosin platform for sharing information. So you can register and say, hey, I'm with a bank, and this is my position. And so they can ensure that you're going to receive the alerts that you need for who you are within critical infrastructure. They've done it in a way that it's better. You're not going to get spammed with the actual, here's all the intelligence we have with this. We're trying to do this smartly, better, right? You guys should be given this brief, this part of it, right? But it's, you have an alert, so you can go in, so you've been validated, right? As you are with this entity here in Utah, and you do need to know this. So you can take a look at, okay, here's who's doing what. Here's the tactics, techniques, procedures maybe being used against you. Here's indicators of compromise, along with, hopefully, right, here's the steps for mitigation. So that's something I would highly recommend you take advantage of. Okay. I told you, this is just resources in general, and I'm trying to go fast to get to the end of my slides, and I want to leave some time. I got like 10 more minutes, okay? So this is the money, so the grants. So they call it the State and Local Cybersecurity Grant. Utah is set to receive about $10.6 million in the next 4 years. This money is specifically for the state, the local governments, municipalities, cities, counties, right? For them to build up resilience in critical infrastructure. Think about it. If you're a county, you're probably hosting, what, emergency communications, you got elections, you've got maybe a water system. You know, there's a lot of critical infrastructure that's on that network. That's the priority for this money, okay? A lot's being done, and that's what I just wanted to give a little placeholder and then just move on. But I think I'll just leave it at that. But it's not quite available. The state's still applying for it. They're creating the plan to bring in the money. And then also within kind of the plan, it's how to push out the money, okay? So again, if you have additional questions, I'm going to probably turn over a lot of that to the folks at the Cyber Center at the state that are really working at the plan, okay? Because I'm kind of in my role as the CISA piece of it to the state, and then they're working the plan with the state to push it out to where it needs to go. And keep in mind, a lot of stuff here in Utah is done under enterprise infrastructure. It's really smart approach for how they're going about it. Okay, I wanted to bring this up too. So if you're not aware, Utah has recently enacted, or we now have a commission, a cybersecurity commission. Okay, so it was enacted into a House bill just back in May, so it's still in its infancy. Along with this group, 40 plus people, again, representatives from every sector, a lot of federal agencies, myself, military, National Guard guys are there. They have a representative, FBI, others, right? But a lot of goals that we're really trying to accomplish here in the state. So it's really awesome to be in this state with senior leaders that truly care and are doing things effectively. This is one of those things, okay? So I put kind of the bullets on the screen. The why was the commission formed? What are they trying to do? Okay, but I put in this next slide, and this is really the meat and potatoes. So within the commission, they formed subcommittees. You can see those are the 4 areas that the subcommittees are really working for efficiencies in. Okay, so assets and resources, leading principles and recommendations, public-private partnership and engagements, and then incident response, right? So if you're an IT network administrator, you're a cyber analyst, you're a CISO, you're responsible for something in this area, right? And you happen to maybe have an event or an incident, this is going to be a place you can go where you're going to get, everything up front of, okay, goodness gracious, I'm going through this. Who should I report to? What's the recommendation, maybe phased approach to getting through something? What's available in the way of assets or money, resources, right? What are the leading principles when it comes to, cloud storage, right? These subcommittees are working towards pretty lofty initiatives to really help and create more effectiveness in cybersecurity across the state. I put the timeline just so you could see at the end of the day, they're going at it quickly, and it's a lot of work, but a lot of really good people doing this work. So just wanted to let you know that. If you've got questions on this stuff, same thing. Like, I'm not your Utah, I'm on the commission, but I'm not necessarily, I'm privy of some of this stuff, so I could maybe answer some questions, but just letting you know a little bit of what's going on in the state and things you have to look forward to, okay? FedVTE, so this is a training resource. So we put a lot of our money, all these lights, oh my gosh. I really can't see past like row 2. Anyways, lots of free training. So FedVTE, it's not just for federal, employees. It's actually a lot of different training. In fact, there's a secondary login if you're part of industrial control systems for, again, just free training. They try to update these catalogs, keep the training relevant. A lot of money, it's millions, are pushed into this portal and ensuring we're offering because this is where it starts, right? Training to our security professionals on, approaches. Let's say you are, I brought this up already, but I just took a course, but when it comes to, software as a service, or when it comes to your hosted environments, right? What are some of those concerns you should be looking for? There's training on this stuff. If you're looking for certifications, let's say it's a Security Plus certification, or I've even seen CISSP in here, right? Again, a free resource at kind of giving you that education. And so highly recommend you take advantage of this. Okay, industrial control stuff. So Idaho National Labs, they offer multiple courses. This is just a snapshot. I wanted to highlight, honestly, these 3. I've been through these, and they're, quite honestly, they do a really good job at doing this training. I'm not sure if Todd Keller's out here, but he's one of the ninjas that helped to develop a lot of this stuff. But that 301 course, this is for free. It's in Idaho Falls. They also offer virtual stuff these days, but I'd recommend going to that 301 course. It's a 5-day, as you can see, but it's for free. And it's going to give you that experience of, well, for one, what are the leading business practices when it comes to industrial control systems? What are considerations on controls on those types of systems? And a lot of that's going to come in between, that IT network that's hosting typically, an OT environment or system. In fact, that 301 course is really awesome because it ends in a red on blue type exercise where you really get to see, traffic and how it flows, through, for instance, an Active Directory, Microsoft, network, using tools that you wouldn't normally use, Security Onion, Bro, Snort. Like, you get to actually see some of the traffic, what a log would look like for a system that's been compromised. It puts that Greek into English for you, if that makes sense. So really fun. Highly recommend taking advantage of those courses. All right. I've got about 10 minutes, and I want time for questions, but I'm gonna be really fast on these next couple slides. So I have a counterpart here in the state. He's a protective security advisor. So again, when we look at cybersecurity posture, we need to include physical security, right? All the protective controls that make up, host our data centers, right? Gates, guards, locks, doors, cameras, fences, those types of things. So this individual, his name's Matt Boudre, and I've got his contact information. He's available to you too. Again, all voluntary, no cost. And he'll come out, and if you are kind of missing, what's our checklist look like when it comes to physical security? If that doesn't really exist, he'll help to leave you with that, okay? So he does assessments like I do, but on your physical environment. He has a lot of tools that he uses. If you're big and complex and you're, have 28 different locations, he's got a range of tools that he uses to really give you your meaningful assessment, okay? That's his contact information. I'll leave it there for a sec. God did this perfect. I wanted to give myself 10 minutes, and I gave myself exactly 10 minutes. Okay, that's my last slide. That's my contact information. Again, if there's things you're interested in, things you want to sign up for, honestly, if you call, I'm never going to answer my phone, I swear. I try my hardest, but I'm always engaged, doing something. Send an email, okay? And I will follow up. It might take a minute, but I follow up to everything. With that, what questions do you guys have? Oh, that's awesome. That's exactly what I wanted. Is there literally no questions? You guys gave my boss the hardest questions. Okay. Did I hear something? I can't really see either.
Well, that's okay, Rick. I'll shout one out for you. This is Troy. On your tabletop exercises and other things, I've had a recent experience with you guys performing that.
Yeah.
Are those, I mean, you're talking about some of these security resources. Are
Yeah.
Like, how do you guys balance the resources that you have with all of the security request or the security assessment requests? Maybe that's the best way to
Okay, yeah. So as far as hidden costs, and you reference tabletop exercise, I mean, you're hosting it. You know, you're deciding the participants and who to bring out. So those are considerations that maybe lead to resources. I mean, you got to give me some lunch, dude. Not just joking. I come self-contained. But I'm serious. It's like Sean briefed. It's taxpayer dollars, federal agency, lots of money behind the scenes to fund the tools, the assessments, all this stuff, the licensing. Yeah. Yeah. Yeah, that was a 2019, and that's how many we did in that year. In 1 year, and that's an old slide, but I like that it shows it that way. Yep. Yeah. That's what we do. And that's what we do, and I can tell you we're trying to meet, we will meet the capacity. So we are growing the agency to meet the demand. And so when there's a demand, that's the whole point. I need those numbers. I want the requests. And with that, I've got a regional director whose manpower just tripled. And so when I need another 3 people here, I feel like I will get those 3 people. Will I get them tomorrow? Probably not. Will I have them in a year? Yeah, I will actually, probably. So anyways, yeah. Okay. I know. Yeah, that's what I mean. Okay. Hey, thanks again. Appreciate the opportunity. Link up with me, and I'll stay in here if you want any more info.
Test. Hey, everybody. What's up, hackers? All right. Well, hey, everybody. I'm Bill Swearingen. Today we're going to be talking about hacking anonymously. Thanks for coming to my talk. I appreciate it. A little bit about me. I've been doing this for a long time. So I've kind of been in the hacking scene really before I even knew that I was in the hacking scene. I was kind of just thinking back like, okay, so when did I really kind of get into hacking? And I can kind of really put it down to, I remember when I was probably about 12 years old, I got on my bike and I rode it to a payphone and redboxed a phone call to Nintendo for the helpline, right? I think that's kind of where I started. At that time, I didn't even know what I was doing. I didn't really know I was hacking, freaking, whatever. And that really kind of got me into this. Like, I really need to understand, really need to explore and, kind of tinker a little bit. So for those of you that don't know me, I've spoke at DEF CON. I am a founder of SecKC. Let's hear it for SecKC if anybody's heard of him. Nobody? Okay, well, a couple are great. And I started the Kansas City hackerspace as well. So that's just a little bit about me. So real quick, a quick disclaimer. Look, we're not here to be criminals. I'm not here to teach you how to break the law, right? What I'm here to do is to help educate a little bit. I'm not here to be your mama either. So whatever you want to do with this information, I don't care. I'm here because some of y'all are idiots. And I mean that. Okay, but no offense to the other ones. So a little bit more about me. So in my working career, I've done a lot of the same things you all have done. I've worked on the help desk. I've worked on the blue team. I've been on certs. I've been on threat intel teams. And ultimately, where I ended up was I was the CISO for one of the world's largest telecommunications companies. And so when I have some, let's say, background in investigations, believe me, I do. After working for the telco, I went to IronNet, and I was the lead responsible for all of our high-profile investigations in IR. Since IronNet, I've left. I've started my own company with a couple founders, and we provide cybersecurity services for ultra-high net worth individuals. So, just that's a little history about me. But one of the things I really, really want to convey to you, so if you only take a couple things away from this presentation today, is that we truly are living in a very interesting time in history. Okay, so one of the things that you probably already know, but I really want to make sure that I hammer home, is that the capabilities that are available to our governments across the world are simply unbelievable. Okay? Think about what we learned from the Snowden revelations, and they've only gotten better over time. Okay? If you take a look at what's happening in Ukraine or in China, we are seeing massive governments putting in a lot of restrictions and a lot of, just trying to hold down the community, right? And so what we've seen over the last couple years is we've started to see the community rise up, right? So not only are we in a point of time where we have extreme government oversight, but we also have the hacking community rising up and creating our own tools and our own capabilities to thwart a lot of the protections or the restrictions that are put in place, and they're available to us on the internet fairly as a U.S. citizen, pretty easily able to get. And so I just kind of wanted to go through some of those with you. So I just want to make sure that as we talk, I put this presentation together using a lot of resources online with a little bit of my background to say, yes, this is a good idea, or hey, this is how I would do that. But I'll call those out as we go through. Okay, actually, before we move on, okay, I can kind of see the crowd. Is this anybody's first SAINTCON? Wow, look at that. Okay, this is my first SAINTCON too. And so I just want to hear it. Like, let's put our hands together for the SAINTCON orchestrators. What an amazing conference. I gotta tell you, I was simply blown away at this conference, and I really appreciate SAINTCON for putting this on. Okay, so first things first. Now, this is the basic of the basic, right? We're going to get a lot more deeper into this, but as everyone probably in this audience is aware, is your IP address, what you connect to the internet, is your identifier, right? If I know your IP address as an investigator, more than likely, I'm going to be able to get your identity. I'm going to be able to identify you, and I'm going to be able to high-five myself, investigation done, right? But one of the things that you may not know, is that your internet service providers, again, I worked for a major telco, they can see everything that you do online. Everything. In fact, so a lot of the times, what we would do is think about, in that last mile, we would have taps right where your router connects to our network. We would have taps there where we would gather statistics, okay? And it would be all the things that you can imagine, right? It would be more around for performance or just statistics and those kind of things. But they're very valuable investigations. But just before we get going on, please make sure that you're aware that your ISPs, they can see every website that you visit, the time that you spent there, what kind of content you're watching, the device that you're using, and your geographic location. So specifically, as we start talking about ISPs, think about in your home, when you're connected to your ISP of choice, whatever that is, the device that you're using, right, that's leased from the company, maintains logs, okay? And so there are ways when you start thinking through this, right, that you can remove your device's MAC addresses or addresses from that device. You could have your own separate network underneath the ISP delivered router, right? But we'll get into all that here in a little bit. But the point that I really wanted to tell you is ISPs usually retain records of devices and IP addresses for about 7 years. Okay, and so that would be the lease times, the lease IPs and the lease times that you had, the devices that connected to that router that they provided, or that device that they provided to you. But also, when we start really looking at the capabilities that are available to us as investigators, social networks usually keep them much longer, right? Usually it's indefinite. Keep that in mind as we move forward. So, okay, what's our first path as a hacker and we want to start becoming anonymous online? Well, we already know, we're going to obfuscate our IP address, right? And one of the things that you may not recognize, some of you do, of course, but your DNS request, you also have to have a strategy for, number one, obfuscating IP address, we'll get to that, but also into your DNS request as well, right? So ways that we can do this, I'm not teaching anyone new here. Hey, we can just join a public Wi-Fi, right? Then I'm using Starbucks IP address. I'm using Starbucks DNS, maybe, right? Of course, I can use Tor, right? And then maybe there's a VPN that we're leveraging. Well, I'm just going to tell you, none of those are perfect, and we'll go into all of the reasons why in today's talk. But never, ever, ever hack from home, okay? Ever. I'm just going to tell you, if you are like committing crimes from home, hacking or whatever, you're going to get caught, right? So my advice to you is to never ever hack from home unless it's authorized, right? Or it's some TLC home improvement bullshit, right? So hard house hacks, whatever. Okay, so how did this talk even come together? And I'm not kidding you. This is exactly how this talk came together. I was sitting on my couch, and I have a cat. And the cat was like on me or whatever, and I'm watching YouTube, and every single YouTube video is sponsored by some VPN company that is claiming that they're completely 100% anonymous, they're secure, they don't keep any logs. The second you disconnect, they light the data center on fire, and everything. I'm just like, bro, it's not how it works. So just if you take a look at this, this screenshot here, this I didn't put this together. I literally pulled this off of YouTube. from a VPN provider. And they basically, if I can look at this, it's basically saying that if I use their VPN, I'm protected against all cyber criminals and all the governments, and I can just use the internet, right? Well, I don't think that's right. Okay, so one of the things when you're using a VPN, think about how did you buy this VPN, right? Did you connect to starvpn.com from your laptop that you always use, from your home Wi-Fi, right? Did you use your credit card to buy this VPN? All right, so just think about it. When we really start putting together like our threat model about what the VPN provides, right? You also need to think about what information of you do they have. Now, when we start going into VPNs a little bit, no matter what VPN providers say, and I don't care, I don't care what they say, they do retain some sort of logs. Okay, let me give you a good example. All right, who here has ever worked in IT? Right, everybody, right? Okay, so you get a phone call at 2 o'clock in the morning and says, "Hey, this really important user of ours that pays $5 a month, their VPN isn't providing, isn't working correctly, and I need you to diagnose it." Sorry, boss, we don't have any logs. Right? They're keeping some sort of logs, right? They're also, how do they, of course, there's probably logs about when you log in, how long your account lasts, all of these different things. But most importantly, the thing that you have to understand is that these VPN providers are companies, and they are located in countries that have laws, right? And regardless of what statements they make, when it comes down to it, your $5 a month is not worth losing their business about. So let's put it to the test, okay? Let's actually think about, and let's look at history of how well these service providers have protected us, okay? I know you probably in the back probably can't read this, but we all love Proton Mail to send out our spam, right? Well, in 2021, they logged IP address of a French activist and turned it over to the authorities, right? I'm not going to go through all of these, but we've seen Windscribe, double VPN. We've seen Tutanota many times be leveraged, which is a Germany-based company that screams privacy, has been compelled to provide information of their users. Okay, so just keep this in mind. And look, again, don't be criminals. Don't cause people problems. But also recognize that these VPN providers, they're not providing you they're not making you anonymous. They can be compelled to disclose who you are. So let's talk about some good VPN advice, okay? So first of all, and I've already mentioned the threat model, but one of the things that you need to think about is, okay, what is the purpose of you using this VPN? And I know that many of you in this audience are probably way more technical than I am when it comes to networking, but what is the purpose of using a VPN, right? It could be a couple different things, right? It could be to protect your local your traffic on this local network, right? It may be that you need an exit point in a geographically different area, right? But is it to become anonymous? No. So really, you're moving your exit node onto the internet to a different location, right? Maybe as a previous ISP provider, you don't want me to know what YouTube videos you're watching, right? So think about what your real threat model is with a VPN provider, and then implement a counter strategy accordingly. Okay, so if you're truly after a somewhat anonymous VPN, subscribe to a VPN using Tor, right? Never connect to it from your home IP address, and find a VPN provider that would accept a privacy-based cryptocurrency such as Monero or whatever. And so the only reason I would suggest this is like, okay, so let's just say you just got done hacking whoever, and they tracked it back to your VPN provider, and they then were compelled to deliver whatever logs that they had. You want to make it as difficult as you can for them to identify you. Their IP address, it looks like it was a Tor node. They used Monero as payment. Their user ID wasn't Bill swear engine, right? You know, like make sure that you're like think this through. Also, do your own research about VPN providers and never ever tell anybody, hey, I use this VPN service, right? You know, just come on, good upsec there. Okay, so VPNs, look, you're elite, use Tor, all right? Okay, we're going to get much more into Tor here in a little bit, but if both, I just want to tell you right away, and Tor, the Tor project is fantastic. I love the Tor project. There's been a lot of disinformation that has come out from governments about using Tor, right? If you really want to see disinformation, go look at people that talk negatively about Tor. Some of it may be good, I don't know, but yes, there are strategies that governments take to de-anonymize Tor, right? If there is a suspect, if I believe that you are the suspect in this case, I can monitor the time of access and the amount of data that gets brought into the Tor network and it exiting. If I monitor to those two things, I can start to de-anonymize you there. There are strategies that can be in place that can be used to de-anonymize Tor. Like I said, we're going to come back to that here in a little bit. I just want to tell you it's not bulletproof, okay? Okay, I know I've already said this. I'm just going to keep saying it every slide, but if you take away nothing, this is the rant part of the talk, and this is what my favorite part where I just get to go here and like yell at you. Okay, so do not hack from home. You will make a mistake, all right? How many times, like, you criminals been there and you look down and wire guards disconnect and you just start panicking because, like, when did it disconnect, right? That's not how you're going to get caught. You're going to get caught because you're using the same laptop that you use for work. You're using the same laptop that you use for home. You're going to, like, accidentally be logged into Instagram or Facebook or Google or something, and this is how you're going to get caught. No matter how much energy you put into having a different identity using VPNs and Tors, or Tor, this is how you're going to get burnt, okay? And I'm going to tell you a strategy on how to get around this, but all of these social networks, number one, they retain information about your computer and your habits indefinitely. They're using that information to make their networks better, all right? And the minute that you log in to one of these services, and you don't even really have to even log in. If you were just to hit an asset of one of these, you go to a website that has a Facebook login button, just that action, if you're using a laptop that you've previously logged into Facebook with, that's all that we need in order to start de-anonymizing you, right? So do not hack from home. You will make a mistake. And when you look down and you see that you're logged into Google on this laptop, even though you're using a Tor browser or Brave browser or whatever, you look down and you see that you're logged into one of these services, I just got to tell you, you're burned, okay? So, like, you're just, it's the end. And so you really need a different strategy on how we're going to do this. Okay, so how do we stop that? Well, first of all, you got to remember your OPSEC. So I just want to tell you something. If you haven't seen this already, your computer, your main computer that you use, it stands out like a blinking light to everyone. It looks just like Jason E. Street's luggage at SLC International. Like, and if you haven't seen it, like, you can see, this belongs to somebody. This belongs to a hacker. Okay, we all know this. Hopefully, you guys can see this, but without any tricks or without any tricks, the site or the asset that you are accessing remotely is obviously able to, in order for you to connect to it, obviously it has to be able to get to your IP address, right? And we all probably know that IP addresses can be geolocated pretty succinctly now, right? So I don't know if you can see this, but this is, I just went to privacy.net, and it showed me my IPv6, and it also told me that I was located in Lenexa, Kansas, and I was using Charter Communication as my ISP. It told me my browser, and it told me my OS, right? We pretty much all know this, okay? That's not a surprise. But again, using very, very similar tricks, we're able to fingerprint these computers without running any code. So without running any code, this website, privacy.net, was able to create a fingerprint that would individually identify this laptop right here without storing any cookies, without running any code locally, because of the browser that I'm using, the OS that I'm using, the screen size that I'm using, et cetera. It's able to provide a fingerprint of this specific machine that could be used to identify me later. Okay? So just keep that in mind. Even if we were to have gone through everything with the VPN, right? We super hackers. We went to Starbucks, and then we connected to Tor, and then we bought a VPN with Monero, and then we connected to that VPN, and then we hacked Sony. That doesn't change the fingerprint of this device. That's still being communicated, okay? So that route to the internet, even though we did everything to protect our OPSEC, just because we forgot about the fingerprint of our device, we can still be identified, potentially, okay? So keeping going, we live in a very modern age that you should know that your OSs are spying on you, all of them. Like all of them are spying on you. And so there are a lot of physical identifiers that you need to have a strategy on how to protect when you're online and if you want to stay anonymous. Of course, the ones that everybody knows is our MAC address or Bluetooth addresses, right? But did you know that your CPU has a management platform that has been remotely compromised? The Intel management platform has been remotely compromised before. There's been some exploits for that can read all of those addresses remotely, right? OS is keeping, like Windows and Mac are keeping telemetry on how you use that machine. A lot of applications do as well. If you were to buy a MacBook, okay, actually, let's rewind. We're going to take, I got this brand new M2 laptop, and it's replacing my last MacBook. And so what I'm going to do is I'm going to wipe that MacBook, that original one, and I'm going to use it as my hack top so that I can hack all of these companies. Guess what? Apple already knows who this MacBook was registered to, right? So you got to be very, very careful when you're working with a laptop or a computer of any ways that's been activated with Microsoft, that's been registered with Apple, right? Though just because you've formatted that machine and maybe registered it with a new person or a new identity or whatever, that doesn't negate the fact that that evidence still remains that machine may have belonged to you in the past. Okay. Let's see. Also, did you know that most laptops, even when turned off, keep the BLE radio still on? So even if your laptop was turned off, your laptop, your phone, whatever, may still be beaconing for Bluetooth Low Energy, right? And so what this could allow to happen, or what the investigators could use there, is was this device anywhere near this area? Even if I had it turned off, it still may have pinged the Bluetooth, and we could identify that machine as being local during a certain time. So really the best advice I can give you here is in the event that you want to stay anonymous for whatever reason, maybe, it doesn't have to be malicious reasons, that there could be media reasons, or you just want to stay anonymous, is buy a laptop with cache that cannot be easily identified to you through, whatever the local marketplaces are, that you have here. And also, never, ever use that machine, never connect that machine to your home Wi-Fi, right? Create a completely separate identity that when you're using that machine, you act as a different person. That way you kind of negate that whole logging into Facebook or Instagram or YouTube or whatever. But just keep that in mind, okay? okay, so I kind of already touched on this, but let me tell you something. These things, these phones right here, for whatever reason, let's say that you wanted to communicate, you're in a media unfriendly part of the world, and you want to make sure, and you need to get a story out or something. Well, you know that your phones are tracking you. Okay, so and I love it. Like one of the best things, like I love that my phone, I can go see, like, oh, where did I go last year? And you know, I can see all the places I've been. We all know that it's doing it. It's okay. You can turn it off if you want it. But the best plan here is if you have a smartphone, get a burner phone, and leave your smartphone at home, and leave it playing a video or something, so you can build in some reasonable deniability that you were not in these locations. One of the things that I just think that most people don't understand, probably to the level that this is happening, is that private companies have access to this geolocation, and can determine if any device was in an area at any certain time. Let me give you an example of how that works. So in the event that we wanted to track somebody down, through whatever means, we find that it's coming from this. It came from this Starbucks. This IP address. There are data sets that can be purchased. They're quite expensive, but available to private companies and governments, of course, that can show every device that was in that area at that certain time. So those are called geofencing warrants. See if I can get that word out. And they're starting to become very, very widely used. Okay, so keep that in mind. If you're going to be needing to stay super anonymous, leave your cell phone at home, please. Okay, so let's take a breather. I know I've been screaming at you here for 20 minutes now. Just a real quick recap. So have a dedicated computer, okay? If you truly want to stay anonymous, there's really nothing you can do with the computer that you've been using to make it move yourself to that level that you're looking for. So buy something dedicated. Like I mentioned, create another persona. That persona is the person that uses that other laptop, and that persona does not live in your house, so don't ever connect it to your home Wi-Fi. In the event that you're wanting to use a VPN, make sure you purchase it with Monero. Make sure you connect to it over Tor, and don't use social networks. Okay, moving on. I do want to talk about real quick is building. So you've purchased that computer, and you want to start building it out. So to be a very clever and very resistant to investigation laptop. So my advice. Most of this advice came out. I have the link here in a little bit where they walk you through step by step on how to set this up. But this comes from the Hitchhiker's Guide to Anonymity for full setup. And there's some really clever reasons why we do these things the way that we do. Again, I did not create these, but I agree with all of the statements that were made here. So your base OS, Windows 11 Home. There's a reason. When you go into your BIOS or UEFI, make sure that you set up both set up passwords for everything, for boot up, for setup, and on hard drives. Disable Bluetooth in the BIOS. Disable any management interfaces that may exist in the BIOS. A lot of times you don't have access to this, but as you're installing your Windows Home, disable the OS telemetry. There's guides in there as well. And then finally, you want to use Veracrypt full disk encryption with plausible deniability. I'll get into that in a second, with memory encryption and memory wipe when you insert a USB device. Okay, so why Windows Home 11 or Windows 11 Home? Well, so a very interesting feature of Windows 11 Home is it does not come with BitLocker by default. Okay, and so in the event that you can imagine, like someone were to steal your laptop, they believe that you have you're a reporter, and you've disclosed some information that you should have, and they take your machine from you, and the investigator goes to look at your machine, and they find Windows 11 Home, and you've got VeraCrypt installed. Right now, you have plausible deniability. If somebody would say, well, Bill, why do you have VeraCrypt installed on this machine? And you can say, well, I take security very seriously. I wanted to encrypt my machine, and Windows 11 Home does not permit me to do this, so I went with a third party the third-party software to do that. Okay. Well, we're going to need you to decrypt your laptop, Bill. And I'm like, okay, well, because I've set up plausible deniability in VeraCrypt, I can, for those of you that have not seen that, it's basically, it's layered encryption. If you give one password, you get this result, and if you give a separate password, you get a completely separate result. That separate result could be your hidden OS, right? So it would look something like this. So you would have your decoy operating system, that being our Windows 11 Home, and then when you start to decrypt, if you were to give the plausible deniability password, it opens up that outer volume where you would leave some evidence for the investigators to find. Okay, it doesn't matter what. It could be documents, it could be pictures, or maybe like some movies or something. Something that you. Like, I didn't really want anybody to find the movies that I downloaded or whatever. But that exists in that outer volume. And it gives you some reason for you to have encrypted that volume. Meanwhile, you have a separate hidden volume that contains your actual operating system that you would be in your hidden operating system. Again, I don't have the time, nor am I going to talk you through the setup of this, but the Hitchhiker's Guide has step-by-step installation and configuration for all of these things. It's also worth noting that you need to be very careful about memory encryption, and so there have been attacks on this. You've probably seen that you can retrieve memory even when the machine's turned off, but VeraCrypt has ways of wiping the keys when your machine goes into hibernate, or when a USB stick is stuck in, and I would really recommend that you do both of those things. At the end, it's going to look like this, like your laptop is going to look something like this at the end. And I just kind of want to talk through this a little bit. So basically what we would have is in our decoy OS, we would disable all internet. All right, the way that we would do that is we would remove the gateway IP address from that Windows Home machine. We would then have that VeraCrypt set up in a way that we could run VirtualBox running off of that decoy OS volume, right? And then we would pipe all of our internet using WAPX bridge over to Tor. All right. I understand this looks complicated, but it's really not that bad once you set that up. But what you've done in this setup right here is completely create a scenario where you're not going to make any mistakes, right? So you're forcing your connections over Tor, you're using hidden OSs, you're like doing super spy shit, and it's all fun. I know. That's a complicated slide, but believe me, it doesn't take much to get there. Okay, so I get this question a lot. So once I connect to Tor, should I add a VPN over Tor? So should I VPN over Tor, or should I Tor over VPN? And both of them are, there's yeses to both. Again, Tor is a fantastic capability, but again, it's really just changing where your IP address lands, right? So if you remember back when we were talking about the social networks and all of those kind of things, that's how you're going to get burned, right? Even if you're using Tor and you hit a Facebook login, it's going to de-anonymize you right there, right? So just make sure you consider that. But considering your threat model, so if you have established a Tor connection, and you're connected to Tor, and then you create a VPN connection, you're actually reducing the security of Tor. It bypasses Tor's stream isolation protections, but it does provide you some capabilities. So for those of you that have used Tor in the past, you know that some IP addresses just don't respond to Tor connections, right? There are a list of Tor exit nodes, and some places just either don't route or block. So you may need to leverage a VPN to be able to connect to that. So if you were to establish a Tor connection and then establish a VPN connection over that, you would then be using the VPN's exit node to be able to access those resources online. Those resources would not know that you are coming from Tor, even though you kind of sort of are. But really, you're reducing the capabilities that Tor is presenting to you. Tor over VPN is really maybe a better solution. It causes some slowdowns, but it's just using Tor. So what that would look like is you would establish a VPN, right? So then what you're doing from there is you're preventing your ISP or anybody that may be watching. You're preventing them to see that you are establishing a Tor connection, right? The VPN provider would still see that, but your local ISP would not. But then, of course, remember your VPN OPSEC. So that still goes back to all of that. Okay, and so finally, the very last thing is just don't be an idiot and don't brag about what you're doing online. Like literally, I pulled this offline. Like this guy's claiming that he's hacking with Anonymous and but posting it from his Facebook account, and he wonders how he gets caught. So I hope this was helpful. On this next slide, the QR code takes you to the Hitchhiker's Guide, and it's just anonymousplanet.org if you don't trust QR codes. But it's about a 400-page document that is really set. It's built. It'll go through everything that we talked about here today in much greater detail. It will give you clear setup instructions on how to configure everything. And with that, thank you, everybody. My name is Bill. So, thanks.
Signing up on Shopify.
This is Possibility, powered by Shopify. Sign up for a free trial at shopify.com/listen22. Shopify.com/listen22.
Yep. All right. 111. Check, check.
check, 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 check. Okay. Check, check, check.
One, one, one. Check, check, check.
All right. Hello, everyone. And today we'll talk about the databases and how do we hack open source databases, pen testing, MySQL, and PostgreSQL. And my name is Alexander Rubin. I am principal database engineer at Amazon Web Services. My background is MySQL. I have been doing MySQL consulting for a long time. Started at MySQL AB, the company behind MySQL. I joined Amazon RDS, Relational Database as a Service, in 2020. And I joined as a database engineer working on MySQL, but then I switched to doing security. And security was my personal hobby. It started playing capture the flag games and doing security research. So I'm currently leading what we call the Red Team, RDS Red Team at Amazon Web Services. And I also have my colleague Martin here. Martin is a member of my team, and he's working on database security for 17 years. He joined in January this year, and he's doing lots of penetration testing on various AWS services, focusing primarily on databases, but other services as well. So let's see what this talk is about. So January, when you think about how do you pen test a database, you may think, well, first let's run nmap and see if the port is open, right? And then we'll try to do a brute force of passwords, something like that, right? That's usually not the case. The more common scenario is we have an SQL injection. And we will start with this scenario where our initial entry point into a database is through the SQL injection. And this is a common SQL injection scenario, right? And this guy is me looking at this stuff here, right? So how come? It's very simple. It's pretty bad. We have this customer input. We have this like user input in there. And it's pretty easy through this SQL injection to get into the database, right? And then the next thing what an attacker will do or pen tester will do, right, is to try to get into more deeply into the database. And in case of MySQL, MySQL has this users table. And this user table stores the username and the hash of the password. So we'll try this. But that was too easy, right? So what if we don't have an access to mysql.user? What kind of scenario we are talking here? So let's look at, we look through the typical entry point as a SQL injection, but what really is there? And this is a sample architecture, totally fictional architecture here, right? But this is more common scenario where we have different applications in different databases. And we have, in this particular case, we have what is called multi-tenant applications. So let's imagine that this is a healthcare records company that stores the health records, PII, PHI data into the health database. But they also have a WordPress website, which is just information about the company, right? And then we can totally imagine, I can totally imagine that an attacker will find an SQL injection in WordPress, which is notorious to have SQL injections, and get into the WordPress. But there is nothing interesting in the WordPress. So our goal is to, as pen testers, is to try to access the health records database. And in a good multi-tenant databases, there is a isolation. And MySQL provides an isolation method where if you have a full access to the WordPress database, you will not be able to get into the health records database. So what I'm going to do next is I will demonstrate how a specific attack called confused deputy may help us to switch and break this isolation between the databases inside the single database instance. So what is the confused deputy problem? So confused deputy here is a computer program that was tricked by another program to do something. And usually this another program doesn't have specific privileges. And this confused deputy program has enough privileges. So we confuse the deputy to do something that we don't have privileges to do. Let me give you an example. So let's say that we are on Linux, and we want to make sure that all files in the home directory is owned by that specific user, right? So we created this cron job to run on every minute to do the chown command on the home directory, right? That's a good idea, right? So we need to make sure that all the files inside of the home directory are owned by that user. So what can go wrong? Actually, there are lots of things that can go wrong here. So I have recorded this video, this screen share, to demonstrate this. So let's see. So how does it work normally, right? So I created as root, I have this cron job, right, first of all. Then I create a file as root in a home directory of EC2 user, which is unprivileged user. And then, because we have this cron job, it will run, and it will fix this problem. It will chown this file to be owned by EC2 user. So in a second, it will do that. Not yet. Not yet. And here we go. So now what can happen is a bad user can actually create a symlink from that user inside the home directory to etc password. And what will happen is that our cron job will be our confused deputy. So our EC2 user is trying to confuse our system to give it more privileges. So our cron job will run, and what it will do is it will follow the symlink. We can create a symlink to any other file on the system, right? So when it follows symlink, it will actually chown the etc password and change the user of etc password to EC2 user. So in a second, it will happen. It just happened. And now, this EC2 user can edit the etc password and obtain any privilege they want. Right? We can create another root user. We can change the EC2 user ID. We can do anything. So basically, we have successfully executed, by creating a symlink, we have successfully executed a confused deputy. We confused our cron job into doing something malicious. Now that we know how it works on Linux, let's see how this applies to the databases. So again, we have this architecture, just to remind. Our goal is to get into health records database, and the MySQL database is sort of protected. So let's dive deeper into this architecture and see what do we have on the MySQL part. So we have a number of databases. We have a corp WordPress, well, it's actually users. We have a number of users here, right? We have corp WordPress user that have all and every access to the WordPress database which have absolutely nothing interesting in it. And we have health data service user, which have all access to the health records. But in addition to that, we have this monitor user. So what is this? Let's take a look at a list of the privileges. So again, we have core WordPress user, which have all and every privilege on the WordPress database. We have health data service user, has all the privileges on health data service, which is what we are attacking here. And we have the monitor user, which have select and execute. So it actually has a select on star.star. That means that it can select from all and every database. But it also have just select. It doesn't have an ability to write to the system. So this user is used for, usually is used for performance monitoring system, or can also be used for as a database administrator. So the question is, can we confuse this monitoring system into giving us an access to either MySQL database or healthcare system? If we will try to use this, our current user, which is WordPress user, and we'll try to select from the MySQL user, there will be no access, right? Because it's not allowed to read this user and passwords. But if we will do that from the monitoring user, because it has a global select, it can actually give us the passwords. So let me get a little bit deeper into what the database performance monitoring do. So it's usually a system that helps database administrators, and it collects the database metrics, it collects slow queries, and it also, what it also does, it generate explain plan. An explain plan will help database administrator to understand why the query is slow and how it goes. So what database administrator do? Review database metrics, collect slow queries, and actually use explain plans to optimize the queries, right? So now when we know what the database operations are, we can see deeper. So let's take an example of this explain plan. When we run the explain, we rerun the SQL statement with the explain prepended to it. And it will take this in a typical scenario. A database administrator, a database engineer will take the slow query and run explain plan. So what does explain plan do? It doesn't re-execute the query, right? So if we run this, it will never execute select query again, correct? Actually, in some cases, it will. And let's take a look at what cases and how it will work. So that was actually a known thing for a long time. Well, relatively long time. In 2020, Percona, a database consulting company, has published this blog post about a case where an explain plan can actually re-execute the select query once again. And this is really bad for various reasons, not only for security. If someone was doing something and you re-executed this query again, then you make the database inconsistent. So in this example, we create a subquery. And the reason why it actually re-executes this query is because it needs to calculate, it needs to collect the statistics and metrics. So to actually create the adequate metrics, it will need to materialize this subquery. So it will execute this query, and this query will run for a long, long time. Now, how can we use that, and how can we escalate the privileges? So what we will do is we will, first of all, in the WordPress database, an attacker can create any objects. It can create tables, functions, etc. So let's create a proof of concept where we will intentionally generate a slow query with a subquery in it, and we will try to grab the username and password from the MySQL system database. So what we'll do first is we will create this proof of concept. We'll create an exploit function. And this exploit function, inside of that function, we will select the password, which is called authentication string in MySQL. And we will also make this query slow. So what we will do is, inside of this function, we will check if the user is monitored or not. If it's not monitored, then we will just simply make this query slow, so it will be picked up by the monitoring system. And then if the query is executed by the monitoring user, we will just simply select. But the question is, how do we obtain this information? How do we send it back to our WordPress user? Give me a second. For some reason, my Mac is not charging. Can I get a working power? All right, where we are. So the question is, how do we send this back to our WordPress user? Right, and the answer is that there are another function that we can use, and we can use a definer. So the definer in a MySQL database works as a suite bit. Whenever you execute a function which have a definer in it, this function will be executed in the context of that user. So we have created this function with a definer of our unprivileged user. Yeah, let me switch that. Okay, thank you very much. All right, so we will create this function with a definer of our unprivileged user, and remember that we have the ability to insert. So what we'll do is we will create another function. We'll create a save function, which will allow us to actually save the password into a table that we fully own and control. So let's take a look at the final proof of concept. So we create this function called exploit. Inside of that function, we retrieve the password, we put it in a variable, and then we run another function which specifies the definer. So that will allow us to save the password into our table. And then we'll make it slow. So now we can save this admin password, and we can just simply execute the select query. So I have recorded this demo, and let's see how it works. So I have all these functions prepared here. And let's make sure that we have a correct user, current user. Our current user is corp WordPress user. And now I have prepared my table, P, which will have the password saved into it. And now I generate the slow query. So I will have a select start from, and then I have a subquery here, which will just select from just use the exploit function, right? So this is a slow query. I make it 3 seconds. So now this query will be picked up by the monitoring system or even by the database administrator. And this database administrator will go here on the other side of the screen and run the explain. And then the database administrator will be confused. Why this is not slow anymore? What happened? But now our user actually can select and see this is the password. So we successfully retrieved the admin password, and we could have just selected anything from the healthcare database. So now, in this particular example, we obtained our monitoring password, right? So now we can reconnect using a monitor user and this password. But the problem is this is not the actual password. This is a hash of the password. So next thing what I will do is I will start up my GPU EC2 instance, 8 GPU cores, and run the hashcat. And I will use the ROCU file to basically try to get the password out of that. And let's see how quickly it will work. So I created this, I removed the star from the beginning of the password so that it will work with a hashcat. Star is just a MySQL specific. And let's see. So it just less than a second, right? And the reason why, the password is pass. And do you have any idea why the monitoring user has this super simple password? Because nobody thought that this user is important. As some database administrators set it up quickly to be able to get the metrics on the database and set up this highly unprivileged user and set up a simple password. So to recap, what we did so far is we confused our monitoring system, or we confused an actual person, DBA, into run and explain on statement. We have created on purpose this malicious SQL statement that retrieved the data that we normally will not be able to retrieve. All right, and that worked actually because monitoring user had global select and execute privileges. So we got a monitoring user password hash. It was a simple password, very easy to crack. And as a result, an attacker can connect as monitoring user and get the healthcare data. So this part is done. In our particular scenario, what we did is we went from the SQL injection, get some random WordPress database. With this multi-tenant architecture, we're able to utilize the monitoring system to get into the health records database. All right, this is a totally fictional scenario. And first of all, what about PostgreSQL? It is much more complicated, but still possible. I don't have a proof of concept yet. If I will have a proof of concept, then I will present about that at some conference as well. All right, so where we are. So at this point, we used an SQL injection, attacked the relational database, and get a full access to the relational database. Can we go further? So what will be our next step? Our next step will be what is called database escape. And Martin will be talking now about the methods and how you get the escape from the database.
Thank you. Hi, everyone. So in this part, I will talk about getting from a database to operating system, establishing a footprint on OS from database. So what do we have? We have access to a database with the highest privileges. We are an admin on a database. And what we need to do, we need some sort of command execution, operating system command execution. Ideally, it should be privileged, but unprivileged will work for us as well, because we can later use some sort of LPE to get more privileged access. So let's do the first part. We will work on MySQL first. I'm sorry, we'll work on Postgres first, then MySQL. In Postgres, it's relatively easy as long as you get a database administrator access. On MySQL, it's a little bit more complicated, but it's still doable. So for Postgres, we can do two things. We can use a statement called copy table from program on Postgres, as long as we are admin on a Postgres database. Or we can use an archive command as well. So how does this work? I did a small demo here. Hopefully it's readable. This is a connection to a Postgres machine. First of all, let's examine if there is a file on disk. Under TMP, I'm looking for SAINTCON text file. It's not there. Now let's connect as a Postgres, which is an admin, to our database, and do a create table. We need this table as a prerequisite for the copy statement to work. This is a dummy table. Its format is not important. Okay, we have a table, and now we run this copy table name from program statement, which is allowed because we are admins on the Postgres. And as a command, I will supply a simple touch TMP SAINTCON. Good, let's check. The file is there. It's easy, right? Okay, moving on. Let's try to do the same with archive command. This is another option in Postgres. Again, let's double check that there is no file yet on the TMP. Nothing yet. Connect as a Postgres, which is an admin. And I do alter system, set archive command to my command, which again is touch TMP SAINTCON. You can do that, alter system, because you're an admin within Postgres. And another command, I enable archive mode. It should be on or always for this to work. The only problem here is that the server needs to be restarted or recycled after the alter system set archive mode is changed. So here for simulation, I just restart the service, but in real world, the bad actor can just wait for the server to reboot after, let's say, operating system update or something like that. Okay, we restarted, and the file is there. Pretty easy. Now let's look at the reverse shell example. Again, Postgres. I have my Windows split into two parts. In one, I will run a netcat, and another one, I will do the PSQL. Thank you. Okay, we are connecting as an admin to Postgres. Again, we do create table, our dummy table. And then we start a netcat listener on the same machine just to make it easy. And now I use a payload which will connect to my netcat listener. And as you can see, I can run commands. In the real world, because attacker will use a remote address, remote IP. So that's the remote shell for Postgres. Now, a MySQL part. In MySQL, it's a little bit more tricky, but still doable. So what we do, we create a table first. We upload our binary payload to this table. and we export data from this table to disk. And then we use exported file as a source of user-defined function, which will allow us to run commands on the machine. All right, here's how we create a file. We connect as an admin root in case of MySQL. Switch to MySQL database, create a table, and just insert some value into this table, and later we'll export that. So here I just pick a simple 4-byte value. For this demo, but in reality it could be any binary. Okay, this is an insert, and now I do the export to a local disk of a server. Before that, I will examine the plugin directory location on this machine to be able to write directly to this plugin location, which will help us later on. So I do show variable and just repeat this select into out file. There is one prerequisite for this to work. The secure
file pref
setting should be set to an empty value. All right, as you can see, we have been able to write to a disk with 4 bytes. But like I said, it could be any binary. Next part, let's create a function which will help us to run operating system commands. This is a source code. You can easily find it on a GitHub, I think. I'm sorry.
Mm-hmm.
It's function definition.
Mm-hmm. Let me see.
Yep, so here you can see it's very simple wrapper around the system C runtime function. And what we do here, we just compile this into a shared object on Linux. And using technique from previous slide, we can upload it to a file system of MySQL machine. It's just a ELF file. You can create a program to upload it through insert to a table and then export it. And the final step, common execution. Here we again test for file existence before we do anything. File is not there. We connect as root to MySQL. When we create the function here, referencing our uploaded UDF shared object, and just do select using this do system function name to create a file. Let's check. The file is there. So that's a MySQL demo for common execution. And like I said, after we got basic common execution, we can do another step, try to escalate to root, for example, on a box. That's
all right. Thank you, Martin, for the demo. And the final step here is how do we move laterally? So at this point, again, we had been able to start with the SQL injection, escalate the privilege inside the database. get into the database server itself using unprivileged shell and possibly even escalate to root. We haven't looked into how to escalate to root, but so the next thing, we will try to actually move laterally. And usually how does it work is if we want to move laterally, right? We want to switch to move to the application server. So application server connects to MySQL to do something, right? In this particular scenario, we use SQL injection, we hit the application server, but with the SQL injection, we don't actually have an access to the application server. We connect to the database. So how do we try to get into the MySQL client? So what we will do is we will use this rogue server technique, and we'll try to read any file, arbitrary file, from the client. So here what we'll do is, again, if you are on the database server, you are running as a user that runs this database server. It's usually not root. It's usually something like Postgres or MySQL user. But you have the ability to shut down that server and start something to replace that. And this user will be able to bind on the same port. So what we will do here is we will replace our normal MySQL server with a rogue server. And when we replace that with a rogue server, we will trick MySQL client to read any file from the client host. This vulnerability has been known for years. And the good news is that in the recent MySQL versions, this is not possible. Again, I also want to say that MySQL has much more secure defaults now. Like what Martin has demonstrated will not be possible with the default configuration. But with this rogue server, we can at least try to trick, again, our client that connects to MySQL to obtain a file. So how does it work? MySQL has this load data local in file command. And what this load data local in file command does, it actually tells the client to read the file and send it to the server. That was a common way to import the files into the MySQL table. But what is also interesting about this is the server can tell the client, give me a file, and I will put it in a table. But with a rogue server, we can actually reply with this packet, load data in file packet, to any connect. So this is basically the work that has been done by, in 2018, to trace the MySQL protocol, do the Warshark TCP dump on the MySQL connection, and those guys realized that there is a capabilities flag. And when you say this capability flag, it actually can trick the client to send the server arbitrary file. So with this, we can actually try to move laterally. We can try to read etc passwords. We can try to read whatever else. We can even try to read etc shadow if the client is running from root, which is unlikely, but still. So a quick recap. We went from SQL injection to escalating privileges, downloading the healthcare data in our fictional example, to running commands, shell commands on MySQL server on Linux, to moving laterally, moving to the client. So how do we fix that? So first of all, obvious, protect application from SQL injection. Use prepared statements, sanitize the input, and also grant only what is needed. You don't want to grant select star on star to some monitoring user that you not even know about. And always use the latest versions. MySQL, PostgreSQL. MySQL specifically has now much more secure defaults, and none of those privilege escalation that we demonstrated, starting with Martin's demo and my lateral movement, will not work. So that's all that I wanted to talk about. Again, my name is Alex, and I'm also building this team, which is a new team, not so new anymore, but I'm building the red team at Amazon Web Services. If you're interested joining my team, doing some penetration test on our services, please come to see me. All right, and I have some time for the questions, if anyone have. Yes?
You showed in Postgres there was like a copy command or whatever.
Correct.
And in your conclusion you said use latest Postgres. Does it actually solve that problem?
No, you're right. You're absolutely right. That's a good call out. The copy command is not necessarily fixed. So the PostgreSQL and MySQL has a different, what I would call privilege model, right? And the Postgres community always said that the super user, the root user on Postgres, have the ability to execute the commands. And there are tons of ways how we can execute the commands as long as we have the root user. But the prerequisite of that is to be able to obtain that root user, the super user, right? So, and the normal user that is connecting to the database doesn't have that capabilities. In MySQL, it's a different privilege model. It's different user auth model, where it's much simpler. It basically have the database level privileges and table level privileges and other stuff. But in MySQL, even if you have a super user on the database, you're not supposed to have anything to be able to execute the commands, unless you make this insecure default or insecure configuration. Yes?
Is there a way to block the super user from running commands without affecting Postgres itself, like being able to do what it needs to do for its normal interface?
That has been discussed with the Postgres community. One of the things is that Postgres allow this archive command. It basically implements the, I think it's redo log, right? It's a redo log archiving through the shell command from the file level. And that's why it have this capability to execute the shell commands. And this is what we have abused. I would totally love to have a different model in Postgres where we can configure it and say, absolutely no shell commands execution equals true. But it doesn't exist right now, as far as I know. Any other questions? All right. Thank you very much.
want to take it off, let's take it off now.
Let's just take it
Here,
off.
hold on, wait.
Sorry.
You're good. Okay, cool, you're good.
Over here, fine. You need to put it somewhere else.
That's fine. Actually, I probably will take it down, just so
Oh, no worries.
it's not in video. Okay, I'm gonna bring, and this is just so you can like gesture and stuff without getting caught up in the cord. So go ahead and tuck that in your pocket.
Okay.
And it has like a little clip on it, so it should just clip right on. Hit me with the checks.
Test.
Go louder. Check.
Test.
So I'm just gonna keep the level down, but it's just gonna stay on underneath.
Okay.
We'll at about 28 or 29. I'm gonna go back and shut the lights off, and then we'll start recording and going. And then when you get to start talking.
All right.
He said he likes to walk around, so I'll just back him with the camera. Perfect. And then
I'll try not to go crazy for you or anything. Although I do need to use the restroom, so I don't know. Maybe I will be walking around.
I mean, if you want to go now, now would be the chance. You want to go?
Is it around here?
Yeah, it's just here.
I'm gonna take this off.
I'll take it. Yeah, I'll take you to back there.
Can I just take this off?
Yep.
Wow.
Check. My name is DB Chuck. You can reach me on Discord. I'm very famous. I'm also in the 5th row here on the stage right if you want to talk to me about operating systems. Very big into operating systems like Mac OS. Thanks, everybody.
Test, test, test. Okay. I'll just wait for you here and tell me, and I'll go on stage. All right, how you guys doing today? Come on, that was weak. You guys can do better. All right. Now I feel like I'm at a con. It's crazy. So, Okay, that's a denial of service attack right there. It's not staying up. All right, guys. My name is Amar Lakhani. That is actually how you say my name. My sister's name is Sarah. I was asked, like, Dad, what the heck happened? Like, could have named me something easier. He always told me, he's like, I named you after a player in Pakistan when they went to the World Cup. I was like, that's great, man. I love soccer. And he's like, no, not that World Cup, the Cricket World Cup. And I was like, what the heck is that? So once you watch cricket, you'll probably have the same idea that I did, or the same thought that I did, is why can't they just play baseball? Seems a lot easier. So guys, my name is Amar Lakhani. I am a hacker by trade. That's what I do. My job really is to find threat actors, find like what motivates them, and really find like the logic behind those threats. It's my job to really kind of understand the coding behind those threats, and then kind of work with machine learning and systems to see if we can protect against them. So obviously I'm a hacker by trade, and I'm a ninja in training. I know it doesn't look like it, but I do study Krav Maga. And they say always, like, introduce yourself and tell them like an interesting fact about yourself. I discovered during COVID I'm a smoker. I know that's a weird thing to say, but I love barbecue, and I started I got a smoker, and it was pretty awesome. All right, that was the only joke I have, and my little niece told me, please do not tell that joke, but I had to. So I've been in the security industry for a little bit, and like I said, my main job is to track threat actors. I was pretty surprised when I started my current position, and we get a chance to work with a lot of law enforcement and other agencies, that how organized some organized crime is. I know that sounds kind of weird, but like some organized crime units, they actually have like the equivalent of account managers that have to sell a certain quota of like threat or crime as a service. They even have recruiting events. I've seen like threat actors have recruiting events and like actually like offer more money to other attackers, saying, hey, come work for us. And that makes attribution really hard, because you used to be able to like look at like coding and stuff and like attribute threat actors, but since they're all recruiting and moving around everywhere, it gets a little difficult. But we always hear about like how sophisticated attacks are and how badass some of these threat actor groups are. I'm not sure if I can say that on video, but I guess that's fine. But I've learned something about the internet, and I don't know if you guys know this or not, but people lie on the internet. Yeah, you know how I discovered this, by the way, is online dating. So I don't know if you have ever used a service like Match or Harmony or even Tinder, right? But people are not always honest about their profile pictures, right? I mean, I wish they could be honest like me. I mean, my profile picture is pretty honest, I feel like. I mean, I know, I did cut my hair, right? We all look better from the side profile, but that's okay. But the internet lies sometimes on like kind of scaring us on like what threats are out there and really what we need to do about threats. And I kind of want to show you how easy it is to do a threat. And I have to be a little careful here, but I'm going to call this the hello world of hacking, because what I'm going to do is I'm going to basically do a reverse shell. Has anyone, you guys all know what a reverse shell is, I'm assuming, right? Okay. So what I'm going to do is I'm going to do a really basic reverse shell. I'm going to take Adobe Acrobat Reader, the install program, and I'm going to insert a reverse shell into it. And this is pretty much real time, right? There's no, there's a copy and paste right here, but besides that, I haven't sped this up or anything. Everything is pretty much real time, and I've renamed this program evil.exe. Yeah, this is not 100% how you do it in the real world. First of all, you wouldn't have a private address on here. You do a couple of other things on here. But as I said, this is really the most basic way I can think of an attack, as well as I've called this evil.exe, right? So you would think that everyone would like detect this attack. This is not even a real attack. Every AV is gonna, trigger against this. And you would hope that would be the case. Now, what I'm going to do is I'm gonna upload this to VirusTotal. Now, just in case if anyone doesn't know what VirusTotal is, it's a Google-run, website, kind of like a Google-run website that has about 70 different security vendors on here, and it scans against these vendors to see if they detect this as a problem or not. Now, this hash has never been seen in the world. It's not a 0-day by any means, but it's a brand new attack that hasn't been seen in the world before. And when I scan against this, you will see a lot of red here. Red is a great thing. Even though this attack hasn't been seen before, These vendors are kind of picking up the logic. Maybe they're looking at some other things. So it's a good thing. Now, I actually am stopping this video early because if I scroll down, there's going to be a lot of green on here. And green is not a good thing. Green means basically they saw it as clean. Now, I don't want to call out any vendor because, first of all, guys, VirusTool by no means is a comparison tool, and you shouldn't really be using it as a comparison tool. But I do recommend to people, like, try your own attacks. When I talk to clients, I go, what is the last attack you saw? They're like, oh, I saw something like 6 months ago. I go, cool. Let's see who picks it up. If it doesn't get picked up, that's a problem, like 6 months ago, right? So I always tell people, like, try these attacks, but it always kind of makes me wonder when we talk about, like, AI, next generation, all these, like, advanced attacks, when we're still not picking up the most simplest attacks, that can be a little scary. And today, that's really what I'm going to talk to you about, is from a little bit from our IR teams on some of the most successful, but at the same time, some of the basic attacks that we see, and maybe a few new things that we're seeing as well. So why do attackers, I shouldn't say hackers, we should say hackers is a good thing, right? Why do attackers attack, right? They asked Willie Sutton, I'm sure this has been used in 1,000 security conferences. They asked Willie Sutton, why does he rob banks? And he's like, well, that's where the money's at. I'm actually going to show you conversations. I get to do a lot of ransomware negotiations. It's sad, like everyone pays these days. Don't pay if you don't have to. But I do ask these ransomware groups, like, hey, why are you doing what you do? And they're like, first of all, because everyone pays. Second of all, because it's so damn easy, right? And I'm going to show you how easy some of this stuff is. So most cybercrime, and I know we got the state actors, we got cyber war happening. We're in a little awkward time, but most threat actors are financially motivated. And that's why I think we see a lot of ransomware attacks, a lot of phishing attacks, because they have these significant immediate impacts to businesses. And these toolkits are very, very easy to come across. It doesn't take that much, to get to some of these toolkits. That's why we see ransomware attacks, service attacks, phishing attacks, impersonation attacks. I want to talk to you about something cool that I started seeing in 2020, and really even this year, started seeing a lot of this. It's called ATM jackpotting. Has anyone heard of that? Okay, a couple of people. So it's run by groups like out of North Korea called Beagle Boys or Fuzzy Bear. NSYNC is part of it. No, just kidding. These sound like boy bands to me or something. So what is ATM jackpotting? Really, it's where thieves install malware on ATM machines, and basically the malware is designed to dispense huge sums of cash. Now, I saw that Breaking Bad episode where they're spending all episodes trying to get into the ATM machine, right? The ATM machine to get into the cash box is very difficult. To get to a USB service port is usually very, very easy. Now, I know I'm not the only one with ATM machines in his garage, or maybe I am, but I like messing around with ATM machines. It kind of makes me feel like, I'm making something of my life. and I imagine there's a lot of money in there, although most of my money is Monopoly money. I still get asked at like Target and Walmart, why am I buying like 30 boxes of Monopoly? And I was like, I need the money. Now, it's been around for a while, but it really started mainstream in the US around 2018. But I got to tell you, around 2020 and even 2022, I've seen like just a lot of large attacks around this. Basically, what these cash crews will do is they'll go around like different ATMs, like around a city, maybe hundreds of ATMs. They're like, okay, at 4:35, we're gonna hit this ATM. And once they do, it's a one and done deal. They've already set it up beforehand. They have special software or code that they put in, and you can't really recover from it because as soon as you know it's there, you're done. They're gone. They're not coming back. And this is just an example. This is kind of an older toolkit, but you can see it's being sold on the darknet for about $4,000. And there's a lot of kits out there. These kits actually come with playbooks that tell you, hey, this is the manufacturer of the ATM. This is how you can double check before you install it. This is how to get to the USB service key, service port. A lot of them, like sometimes they're fully exposed, and you don't even have to like move the ATM machine at all. I have asked the ATM vendors like why they do this, and they're like, hey, you know what? Like we're servicing these machines. They're not like tech guys. They're not like IT security guys. We just need to update the machines. This is how we update them. So we were dogging on them a few years ago for running Windows XP on all ATM machines. They've kind of gone away from that, but this is how they update it to make things easier. But it makes attacks easier as well. And as I said, Some of them get really sophisticated. They'll come up with like cables and stuff, but honestly, it's really just about taking a USB stick, sometimes prepping it a little bit, like depending on what program you're buying, and then sticking it in the ATM machine. So not too much. And these, like I said, these dark kits are available for sale like all the time. When I first started off, like as a threat hunter, I used to have to go to all these onion sites and go on the Tor network and find like a lot of places where to find these attacks. They're all on the ClearNet now. Like, they don't even try and hide themselves. You don't need any more special software to get to these sites. Yeah, sometimes you do need like different logins or different logins to different parts of forums. And they're actually even moving away from that. In fact, this year I'm actually seeing more and more like Telegram groups and WhatsApp private chat channels and stuff where these guys hang out at. And it doesn't take much to get access to it. Just a little bit of I would say patience and just perseverance. And then you're in these groups and you can just monitor what they're doing. And what are they doing in these groups, right? Well, first of all, there's a lot of credit cards in these groups. You can buy pretty much a credit card for about $2 to $5 full credit card. They're selling them, in lots of like hundreds, dozens at least, maybe hundreds, sometimes thousands. People's identity, medical records. I always think like, why would someone want to buy a medical record? Like if I'm not famous, you're not going to really bribe me with a medical record. And I asked some of these groups like, hey, what's the value on the medical records? And they're like, think about it. They're like, a medical record has everything I need for your identity. Has your social security number, has your name, has everything. I don't need to steal a credit card. I can get my own loan by stealing your identity. And then also, I didn't realize how much of a big deal or how much money there is in medical fraud and just running insurance scams and things like that. And there's also kits that walk you through the entire process on how to do that. Now, if you don't have money to buy these kits from the internet, you can just buy money from the internet. That's fun too. And some of this money is actually pretty. Now this is older. In fact, this particular website is probably a scam website. But there are sites out there that do sell counterfeit money, and some of them do actually pass that black marker test to see if it's counterfeit money or not. Some of them you can actually hold up to a light and see a little thread like you would tell people to check for counterfeit money. So it's pretty crazy, like I said, what's out there or not. As I said, you can get someone's name, address, full credit card number, the little verification code in the back, a Stripe clone. A full clone bypass, but most people are not actually going to be buying stuff physically with these. They usually buy things online. They normally look for an address that no one's really monitoring, maybe a house that hasn't been built before, and just pick up the package or whatever. That's normally how they're buying things. And as I said, this is outdated. It's about $1.50 per card right now. That's at least it was a couple of days ago, and it has been around that price for a couple of months. So how do attackers do this? You're like, okay, that's great, but how do attackers actually do this? Usually the first step in an attack that I see is a phishing attack. Now, by far, I think phishing attacks or some sort of email threat is kind of the number one vector most attackers go through. And I'm going to show you really how easy it is. There's a lot of toolkits out there that you can just download. In fact, this one you can get from GitHub. It's called the Black Eye Phishing Kit. And there's like lots of them available. There's like pro versions and different versions as well. And you can download this one. I like this one because it's kind of a fun one to show and demos and stuff. But you can see that in this particular one, I have a lot of templates. I can put in more templates. I can update templates. I'm going to pick in LinkedIn, because everyone likes to send all their information to recruiters, right? Like, hey, I'm a recruiter, and stop right there. Here's all my info. Take everything you want. So in this case, this generates a website for you. This would be the attacker's machine. Yes, you'd probably customize that website, make it look a little more realistic. But once I go to that website, it pretty much looks like LinkedIn. I think most people would get fooled, especially if I have a little more realistic website, customize the actual domain. If I go to the real LinkedIn website, by the way, you can tell it is different. It's like a light theme versus a dark theme, a little bit of a difference. Most people are not going to notice. If I do care they notice, I can update this easily. Now notice when I go to the fake one, it also has that little lockbox. That's what we tell our users, right? Look for that green lockbox, and that way you're safe. This actually generated a certificate on the fly, a Let's Encrypt certificate. So you have that lockbox, so you can all feel safe now putting in this password. So I actually did this to a coworker of mine. This was actually a live attack. He didn't know about it, and then I told him I'm going to use him in every presentation. And He's like, great. My coworker's name is Jonas, and so you can see he's from Singapore. I see some IP information, I see his username, password, and see some other information as well. Now, like I said, phishing attacks happen all the time, and it's funny how they are so good at looking at what motivates us. Sometimes I feel like I get more news out of watching the latest phishing attacks, right? I go, oh, you know what? There must be something happening in Iran right now because I see all these phishing attacks around that, or around elections or vaccines. They're gonna pick whatever they think is gonna motivate you to click on something, right? Hey, Thundercats are coming back. I'll be like, oh yeah, let me click on that. I love Thundercats, right? And so whatever that's going to motivate you, they're going to have a phishing attack on that. And don't think phishing attacks are just limited to emails. They're getting creative now, such as, of course, mobile devices and mobile applications as well. And starting to see phishing attacks on smart speakers like your Google and Amazon devices. So how does that work, right? Well, a smart speaker basically uses a skill. That's an app on a smart speaker. Basically, it has a skill, so when you say, hey, there's no Alexas in here. So, hey, Alexa, tell me what the weather is tonight. So it looks in its database. It says, okay, I have an app or a skill called Weather, and it's going to, tell you the weather, right? Well, people are registering skills that they can use for phishing. For example, if American Express has an app or a skill that you say, hey, American Express, tell me my balance, it's going to be smart enough to know, hey, I'm not going to tell you your balance out loud. Here's a secure link, and go check your balance. Now, what about if someone registers or sees Amex is not taken, and you say, hey, Alexa, what is my Amex balance? It could say something like, your account's being hacked. Here's a link. Please look at this right away.
Your account has been hacked.
I don't know if you can hear that.
Welcome to Amex. Your account has been hacked.
Now, that issue has been fixed for Amex, but in this particular case, it actually sent a secure link. Depending on what device you were receiving it on, what device was registered to your Alexa account, if it was iOS or Android or even a desktop machine, it would give you the proper attack. So the most capable attack it wanted. Like I said, once users get on systems, they do a whole bunch of stuff. They usually will take out data, exploit data. They'll kind of mess around, they'll land and expand. But usually, normally the last step, I always get asked about ransomware. And I hate it when someone tells me, especially a customer tells me, hey, I got ransomware. Because my thought is a lot of other things happened, probably a lot worse before you got ransomware. I normally find that most attackers, they'll execute the ransomware when they feel like they had nothing else of value from you. They're like, I've gotten everything I want from you. Or if they feel like they're about to get caught, like if you start doing some sort of investigation or incident response and like, man, I got caught, let me execute the ransomware. Now, I'm finding a lot of people these days, and I don't know why the trend is changing, but I find a lot of people are starting to pay for ransomware. And here's an example. This is a real life example of this. I did actually take off some screenshots and change some things around just so we can identify the client that easily, but this is a ransom note that someone got. It says, please pay lots of Bitcoins after they got attacked. This was a hospital. It was a healthcare provider. And basically, they went on this darknet channel, and they said, hey, we got hit by ransomware. We want to pay. What's the deal? And basically, the threat actor said, pay us $10 million. Wow, $10 million. And they're like, wait, the note said we would get a special price if we contacted you early. Wow, I can't believe they're asking about a special price. They're like, what's on the dollar menu, guys? So they're like, guys, this is a special price because if you think about the lawsuits, your reputation, all this other stuff, it's gonna probably cost you more. Then this is where negotiations happened. I had to take a couple of things out because they were identifying themselves pretty easily. But essentially, they settled on $4 million. They said, hey, we will pay you $4 million if we can get our data back. Now, can you really trust these guys? The sad answer is yes, you can trust them because they never want you to hesitate. They don't want you to go on a forum and tell people, you know what, I paid these guys and I didn't get my data back. They want you to go on a forum and say, I paid these guys and I got my data back, so when the next guy gets attacked, they have no hesitation. So they ended up paying these guys, and you can even see, they even told them, guys, these are all the things you need to fix, by the way. This is all the things you did wrong. I've actually seen threat actors or these ransomware groups give reports like PDF reports and HTML reports that look better than pen testing companies that you pay thousands and thousands of dollars for. These are awesome reports, and they give you samples and exactly everything what to do. Now, the sad part was this was open on the internet, and just like I found this, anyone can find this, including other threat actors. So, you know, like, even though these guys are probably not going to hack this company again or attack them, other people can go back. They go like, I bet you they haven't fixed everything. I'm going to just attack them again. And you know what? Maybe they won't pay $4 million, but I bet you they won't even think twice about paying $100,000. And I can do the exact same thing again. Now, you can see they actually left the lines of communication open. They're like, hey, you need anything else? We're good. You pay me $4 million, you'll get the best tech support. I'll come hang your TV, like whatever you want, mop your floor. Now, how does this work? The one thing that I found like pretty interesting is that most threats these days, they're kind of run like in botnets. Like when I first started off, a botnet was just like a program that used to attack other machines. It was like a denial of service attack. It used to do a few other things. Now, these days, botnets are actually kind of changing. Maybe we need to update the definition or something, because these days, botnets are almost like me, this is my term, a CDN, a content delivery network, where it just is basically a loader that is a staging for other types of attacks. So I'm going to show you a quick, simple example of a botnet that you can also download on GitHub. You need to talk to Microsoft here, right? So this is called Build Your Own Botnet, but I want to show you like how sophisticated some of these toolkits look like and how command and control look like. This is really how it looks like. Now, this is the free version of this tool. There is a paid version of this tool, or better tools out there as well. So we're going to attack my friend Jonas again, because he's in Singapore. So just don't please attack random people from Singapore. They'll come against me. But in this case, I have like basically executables or a Python script. In the paid version, I can actually do a lot more. I can do a VBS script. I can do a VBS script in an Office document. I can do PowerShell. I can do a lot of other things. But this really was a demo, so I just kind of wanted to show you. We go back on the victim's machine, and the victim has an executable. You'd probably get it for a phishing attack or something like that. Like I said, in real life, this would be an Office document. I do have the ability to actually change the icons to make it look like an Office document, but I would never run an exe in real life as an attack for this if I was an attacker. But you can see once I run this, it normally bypasses all their security, perimeter security, and basically does a reverse shell back. Once I get the reverse shell back, I'll refresh the screen, and I see that basically Jonas is connected back to my command and control server. I have full shell access to a system. I can do other things. I can install more software. I can escalate privileges. I can do, turn on his webcam, put on a keylogger. I have a couple of scripts that automatically do that, or will attempt to do that automatically for me. But at the very end, maybe I'll just install software and give him some ransomware. So a lot of different options that are available. Now, I always ask myself, like, hey, like, why isn't this stuff being like stopped? Like, why is it so hard to stop this stuff? And like I said, it's we don't have time to talk about. This could be like a 2-hour discussion. But what I'm finding is most of this stuff is like hard to catch, because for the most part, attackers are using systems that already exist. They're using like routers, IoT devices. They're not creating anything new. That used to be kind of the old school way. That used to be like 3-4 years ago. They used to like kind of like create new attacks. Now these days they're like, hey, let me try and steal credentials through phishing attacks. And then once I steal your credentials, I'm going to dump your AD, and then I'm going to like figure out where your remote desktops are, and then just get on your systems. And I'm going to use tools that are already in your environment, like PowerShell and other tools. I'm going to create an FTP server, get the data out, upload data. I'm going to try and not touch disk with any new type of programs, because as soon as you touch disk, that's normally where AV programs like turn off or leak, and so it makes it a lot easier for them. They have to think about it a little more, but it makes it a lot easier not to get caught, because when I take, and this is just an example, when I just take a look at like top operating systems that were compromised, and you take a look at multiple lists, you see a lot of routers on their home routers. Everyone's working from home, right? You see a lot of IoT devices. You see a lot of other devices, because people are just like figuring out, hey, what operating system is vulnerable, and let me get on that and use the existing land. We call that in pen testing living off the land sometimes, but that's essentially what it is. Now, I'm going to kind of skip a few slides here, and just because we're kind of getting short on time, I just wanted to show you because I always used to wonder, hey, Amar, you call yourself a threat hunter. What the heck does that mean? What does a threat hunter really do, right? I just kind of wanted to show you, like, my life as a threat hunter, what I do. And Of course, this will be automated in this example, but I'm going to show you basically ransomware. This is real ransomware that I've just changed a little bit, but normally you have your ransomware, you have ransom code normally embedded, or it's a downloader or something like that. And then, of course, I'm going to have some files, and my files could be anything. In this case, they're just like test files, nothing really important, but of course, I could have pictures, I could have office documents, I could have movies, anything I want. In this case, they're just like test documents. But what I'm going to do here is I'm going to run the ransomware. And normally when I run the ransomware, I get a ransom note. Ransom note is the note that says, please pay lots and lots of Bitcoins. I actually had to change this demo because I had a real Bitcoin address in there and people were sending Bitcoins. Like, don't do that. Don't send Bitcoins to attackers. So now I just have this shady address. That won't work if you try and send me Bitcoins there. But sometimes it does some fancier stuff. It'll change the desktop. Maybe it won't even make anything available, just a ransom note. And then usually all your files are encrypted. You can't get to any of your files anymore. And usually wherever you have files, you usually see the ransom note there too. Now what I'm going to do is I'm going to actually put this through the Cuckoo sandbox. The Cuckoo sandbox, I mean, there's a lot of devices. At Fortinet, we have the 40 sandbox as well, but this is an open source sandbox. And what it does is it actually tells me what the behavior of the file is. It tells me like the IOCs of the file, the indicators of compromise. Basically, that's what is all the bad things that make bad, right? It basically shows me, hey, this is when the file was run all the way down to the very bottom when Notepad was open, and it showed me the ransom text. If I go into a little more detail, it's going to show me, hey, these are all the registry entries that were dropped or changed or modified. These are all the network connections that happened. All these different IOCs, all the little bad things. So as a threat hunter, one of the things that I do is I try and separate these out, and I put them in a database. So I'm going to put them in a database. In this case, I'm using the MISP database, but you can really use any database you want. And I'm just going to store all these individual IOCs in a database. I'm storing them, putting them in an event called 1406, just so I can reference them later. Then I'm going to start examining some of these IOCs and see how they relate to another. So I'm going to use this other tool called Maltego. Has anyone used Maltego? A few people, yeah. I love Maltego. It's one of my favorite tools, mostly just because of how it displays information. So I'm going to tell Maltego, look at event 1406. Now, I'm not discovering anything new at this point. I'm not really doing any threat hunting at this point. I'm just telling Maltego, show me what Cuckoo found out about. But I just want to look at it in a little different way, and mostly just because it just shows it to me in a way that I can kind of manipulate a little more. So let's go ahead and run the set here, and we'll go ahead and see what Maltego tells me. And it's basically going to come back and say, wow, these are all the IOCs in your database, including the IP addresses that were connected to. If I had the Bitcoin addresses readable, it would pull that out, the Bitcoin addresses. It would pull out all these other things. So like, great, I've just have another report. So what else can I do here, right? And normally what I do, and like I said, this is from usually, in this case it would be automated, but I'm going to say, what else is related? Do I have anything in my database that's related to these events? Do I have like any other events or attacks that happen that have the same IP addresses, maybe the same Bitcoin addresses, other things of that nature? And that's where I get my start, is figuring out like who did the attack, where did it come from, maybe start tracing it a little more. And then it's just a whole bunch of detective work and really just following the patterns to see where you can find the earliest pattern and like what was the group who started talking about that group first. Hey, are they, was it like Fin 6 or did someone call it Fin 8 at this point because they found out something new about this group, and when did that happen, and just examining a lot of that stuff. So in essential, that's what threat hunting is, and that's what you do as a threat hunter. Plus a lot more stuff like, my boss is here, so I just don't want him to think that's all I do. I do lots of other important stuff too. So I'll just end with one last thing, since I got 1 minute left, is I'll just say, in cybersecurity, it's really about understanding where your weak points are and where your visibility is. And I like the story from World War II because it's a good story. During World War II, the British Air Force was being decimated by anti-German gunfire. And someone said, you know what, we got to protect our planes. We have to protect our Air Force. So they're like, you know what, let's put a lot of armor around us, like our planes. We'll protect them, right? We'll just heavily fortify them. And that's kind of what we sometimes do in cybersecurity. We're like, let's just buy a whole bunch of stuff and hope it works. But that's not how it works in real life. And someone said, like, guys, we can't just do this on our planes because the planes won't fly. They'll be too heavy. They won't be maneuverable. So, of course, they said, you know what, let's be strategic about it. Let's actually look at where the weak spots are. And where are the weak spots? Well, they're like, well, where are all the bullet holes? Those are where the weak spots are. So that's where they're getting shot at. And they're like, that makes sense. And when we think about cybersecurity, we're like, where am I failing? My users are failing phishing attacks. Let me like invest in that. I'm failing compliance. Let me invest in that. It sounds great. But I like this saying because there was a famous mathematician, and he said, guys, you're looking at all the planes that made it back. What happened to the planes that didn't make it back? What happened to the planes where you can't actually count the bullet holes? Where were those weak spots? And that's what we have to look at, right? We have to figure out where are the real weak spots? What are the problems that we don't know about? The way I figured that out personally is I try and do a lot of training. There's a lot of stuff available, and this is all free. Everything that I'm showing you is like free, like training.fortinet.com. I love to hack the box. If you do hack the box for like 6 months, right, you'll be a better pen tester than probably like 15.4% of the people I know. So, no, actually, you will be really good. It's really, like, some of the stuff is really difficult and really hard. It's free. If you pay for the paid version, like, I have no affiliation with this, you get access to older boxes people have solved, right? We have a ton of training available on training.fortinet.com. I actually had my mom go through, like, a level 1, and she's like, I get it. And she's like, yeah, you like, I go, what do you mean? She's like, you're not a doctor. You're Indian, but you're not a doctor. I finally get it. I was like, man, I tried, Mom, I tried. All right, well, I will leave you with that. A lot of good stuff. I'll be around afterwards, and thank you. Appreciate your time.